Somewhere beneath the Pacific, entire mountains rise in darkness. They don't wait for permission. They don't announce themselves. Pressure builds in hidden chambers, sealed under centuries of cold and quiet. And then, without warning, the ocean lifts. Columns of steam that tower past the surface. Rivers of molten rock that cool into glass before any eye can see them. Shapes that weren't there yesterday. Islands born overnight, only to vanish again beneath the waves. Every eruption leaves a mark, not just on the seafloor, but in the water itself. Heat that lingers for decades. Minerals that feed new life in the black. Patterns etched in rock that no current can erase. Tonight, we drift across those places, not to measure, not to conquer, just to witness. Before we begin, tell me, where are you watching from, and what time is it right now? Drop it in the comments below. Let's see how far these eruptions travel, from your screen to the deepest part of the sea. At the ragged edge of the Pacific Plate, the sea hid a wound no satellite could truly measure. A caldera more than 100 meters deep and 10 miles across, pressed flat by centuries of ocean weight. On maps, it was just another seamount, a blue shadow between ridges. But in the last weeks of 2021, the shape began to change. Tide shifted in ways no one noticed. Currents grew warmer. A haze drifted across the water, where fishing boats rarely passed. And deep below, magma stirred in chambers that had been sealed longer than any living memory. The first tremors were soft, too small to trigger alarms. Just a vibration felt through the hull of a single survey vessel, drifting south of the trench. The crew logged the readings, called them tectonic drift, and moved on. But the shaking didn't fade. It grew. By mid-January, hydrophones along the Kermadec arc picked up low groaning, tones so deep, they felt more like pressure than sound. Some called it the mountain waking. Others said it never really slept. On the morning of January 15th, the sea surface split. A blast so violent it folded air into steam, before sound could catch up. A shockwave that raced around the world 3 times. For a moment, every compass needle on the nearby islands swung east, as if the eruption had reminded the Earth itself which way to face. In the seconds after the detonation, the ocean itself seemed to forget how to be water. A column of superheated gas and ash punched upward through miles of cold salt, dragging vapor so high it touched the stratosphere. Those who saw it from passing aircraft spoke of a tower wider than any city, blooming like a white flower in time-lapse. But on the sea below, the violence had no beauty. Waves climbed the caldera's rim in concentric rings, each one building on the last, until a wall of water 30 meters high began to radiate outward. The tsunami warnings spread faster than the waves themselves. Screens blinked red across Tonga, New Zealand, Japan. Radios crackled with instructions. Move inland, find high ground, wait. But the signals never reached everyone. On islands without power, families felt the tremor underfoot before any siren spoke. Some ran before they knew why. Others turned to watch the horizon, believing at first it was just a squall. Minutes passed, then the water arrived, racing past harbors and seawalls, pouring through streets that had never been mapped for this kind of flood. In Tonga, the surge snapped trees like twigs, lifted cars onto rooftops, erased whole neighborhoods in a single breath, and beneath the waves the volcano kept breathing. Each new exhalation sent fresh plumes boiling up from the caldera floor. For hours the ocean churned, not as a single wave but as a restless pulse, rising, receding, returning, as if the eruption had pulled something awake that would not settle again. When satellites finally pierced the roiling plume, they revealed a wound so vast, it defied scale. A hole torn into the ocean itself, the caldera's mouth yawning wider than a city. Steam pillars erupted in rhythmic blasts, each one laced with volcanic lightning, bolts crackling sideways across clouds thick as cement. Ships 100 miles away felt the concussion, hulls trembling under the echo of an explosion that had circled the globe. Some called it a natural disaster, others called it a reminder, proof that the earth below the sea never sleeps, only waits. In the hours after the main eruption, Smaller detonations continued to ripple through the caldera, belching sulfur and ash that stained the waves yellow. The water near the vent boiled at temperatures that no living creature could endure, yet still, fragments of pumice bobbed to the surface, fresh rock made from melt and fury. As the ash drifted across the Pacific, day turned to twilight. In Tonga, survivors gathered on higher ground, watching the sky rain soot that tasted of minerals and salt. The darkness felt absolute, an erasure of horizon and time. For many, the silence that followed was worse than the thunder. The ocean had pulled back, taking homes and history with it, leaving only mud and scattered memories. Days later, when the clouds thinned, the caldera still steamed, a reminder that below the waves, pressure was building again, slow, invisible, patient. It always is. Survey vessels approached the blast site cautiously, their instruments primed to record any movement beneath the hull. Sonar scans revealed something haunting. The seafloor had collapsed in on itself, forming a crater deep enough to swallow skyscrapers. Around its rim, fresh fractures radiated like cracks in old porcelain, proof that the eruption had not merely vented pressure, but rearranged the landscape. Every reading told the same story. The volcano wasn't done. Divers and remotely operated vehicles were deployed, though none dared linger too long. Cameras showed vents still seething with gas, the water above them swirling in ghostly currents of superheated brine. It was a place where the ordinary laws of the ocean no longer applied, where heat and pressure conspired to keep secrets locked a mile below. When samples were collected, they came up coated in sulfur so bright it looked painted on by hand. But even as the machinery worked, the human cost unfolded on the islands. Whole villages lay flattened by waves that struck faster than warning sirens could sound. Families picked through layers of ash and splintered wood, searching for anything recognizable, anything that could prove life existed before the sea decided to unmake it. In some places, all that remained were footprints in hardened mud, leading nowhere. And through it all, the ocean exhaled columns of steam and gas, as if indifferent to what it had taken, as if the eruption was not an end, but simply a sentence in a story that started long before anyone thought to measure it. The satellite images of the eruption would become iconic, great billowing plumes curling into the stratosphere, each rising spiral, a mark of power few living had witnessed. In thermal scans, the plume glowed hotter than any storm, a fever blister on the Earth's surface. Pilots who flew near the edge described turbulence, unlike any they had trained for, updrafts that bucked aircraft hundreds of feet in seconds, and static electricity that sparked across every instrument panel. On the water, it was worse. Merchant ships caught in the radius felt shock waves that rippled through steel hulls, like a hand drumming on a canteen. Crew members reported the air vibrating in their lungs. One radio operator, voice thin with disbelief, described it as standing inside a bell that someone was striking from miles away. Afterward, many spoke of headaches that lingered for days, as if the concussion had rattled something loose in the brain. When the ash finally began to fall back to the ocean, it did so with a hush almost gentle. Layers of it settled over reefs and shoals, burying coral gardens in sterile dust. Schools of fish fled or perished in the plume's path, leaving whole stretches of seafloor as barren as the surface of the moon. Scientists would later calculate that the eruption had displaced more water, more air, more life than any event of its kind in recorded memory. And yet, below the silence of drifting ash, vents still opened and closed, pulsing heat into a world that was already reshaping itself. When the satellite images finally stabilized, they showed a wound in the ocean, a hole where an island had been. The Hunga caldera had collapsed inward, swallowing thousands of tons of seawater in an instant. And somewhere beneath the roiling chaos, a void opened, pressurized gas and molten rock meeting cold brine in a reaction older than memory. The resulting blast hurled ash 30 miles into the sky, punched a hole in the atmosphere so large it was visible from orbit, and sent shockwaves racing across the Pacific. But underwater, something stranger unfolded. Hydrophones listening from hundreds of miles away recorded sounds that had no precedent. Not just the violent rupture of rock, but a resonance, deep, layered, rhythmic, like the heartbeat of the earth itself had stuttered. As the eruption waned, a chain of domed waves spread out in perfect concentric circles. They weren't ordinary tsunamis. They moved too fast, too clean, carrying pulses of heat and ash trapped in the sea's skin. Mariners described the ocean around Tonga as boiling without fire, the waves lifting with a weight that didn't belong to water alone. Even when the sky cleared, the sea remained unsettled. Pockets of rising gas shimmered under the sun, blurring the horizon. Some said it looked like the Caldera was trying to breathe, drawing in water, exhaling vapor, reminding everything above that the volcano hadn't died. It had simply opened a door no one could close. When dawn finally came, ships patrolling the blast radius found the sea transformed. The waves were gone, but a floating skin of pumice had spread for miles, grey, porous fragments drifting together in vast mats. Some pieces were no larger than coins. Others were as big as a man's head, still warm to the touch, hissing as seawater seeped into air pockets. Satellite passes traced the pumice raft across the South Pacific, watching it drift like a memory of the eruption that made it. Fishermen who crossed its path reported a smell that clung to their nets, sulfur, ash, something older than air itself. But it wasn't just the pumice that unnerved them. In the days after the blast, currents changed in ways no chart could predict. Tides ran faster in the channels around Tonga. Warm plumes rose from depths that should have been cold. Even the color of the water shifted, streaks of pale green threading through blue as minerals dissolved into the currents. Marine biologists sampling the bloom found microbes, thriving in concentrations they'd never measured, life multiplying in the chemical chaos. It was as if the eruption had not only broken the crust of the earth, but woken something ancient beneath it, something that had waited in darkness for an excuse to rise. Ships that dared approach the edge of the pumice raft recorded footage later, called unreal. From the bridge, the ocean looked like an abandoned landmass, grey and pocked, stretching beyond the horizon in a vast unbroken skin. When the prow cut through it, there was no familiar splash, no swirling wake, only a low rasp, a brittle resistance that sounded almost alive. Beneath that floating crust, sonar returned something stranger, pockets of trapped gas, huge, spherical, shifting. Some of these bubbles were as large as houses, pressing upward like buried lungs, remembering how to inhale. At irregular intervals, one would rupture, deflating a stretch of pumice with a shuddering sigh and releasing clouds of sulphurous vapor that drifted over the deck. Crewmen stood at the rails with handkerchiefs pressed over their mouths, watching this alien seascape reshape itself by the hour. No current guided it, no tide controlled it. It was a continent of ash and glass, drifting because it chose to, expanding and splitting in patterns no one could chart. The men who sailed there later spoke of a pressure behind their eyes, a density in the air like a storm trying to condense, and some swore they heard a slow cracking beneath their hulls, as if something far larger was still waking. They called it an ocean without water, a place that had borrowed the sea's surface, and would one day give it back, but not before teaching everyone who crossed it a lesson in scale. Farther from the blast zone, islands that had weathered cyclones and tsunamis found themselves buried under a snowfall of ash, so fine it crept through doorframes and windowsills. By dawn every surface was filmed in grey, a texture like sifted flour, but with the weight of ruin. Coconut palms bent under drifts that thickened hour by hour, their crowns sagging until the central spines split and toppled like snapped bones. Water tanks filled with sludge as rain mixed with the ash, transforming what little drinking supply remained into a choking slurry. The sea along the coastlines changed colour too, shifting from turquoise to a dull, sullen brown, where suspended grit clouded the reefs. Families trying to clear their roofs wore masks soaked in seawater, anything to keep the dust from burning their throats. And at night, when the wind dropped and the air finally settled, it felt as if the islands were entombed, every sound muffled, every movement traced by falling powder. In the villages closest to the eruption, No one dared to light lamps after sunset. The air was too thick, too volatile, carrying the taste of sulfur in every breath. When the first relief ships breached the outer curtain of ash, their crews found shorelines erased, boats half sunken beneath pumice drifts, nets hardened into the shape of the waves that had buried them, and whole rows of trees reduced to black silhouettes. The eruption hadn't just scarred the land, it had replaced it. Long after the eruption subsided, satellites still captured trails of pumice drifting across the Pacific, like an unfinished thought. These pale streaks measured hundreds of kilometers, moving with a patient certainty that ignored the currents beneath. From above, they resembled shoals or the ghost of an archipelago, continents conjured from the sea's own bones. But when survey planes flew lower, the illusion dissolved. What seemed solid was a mat of crumbled stone, so light it floated, but so dense it swallowed everything that touched it. Fish schools disappeared beneath its shifting crust, their gills clogged before they could flee. Turtles washed ashore starved, their beaks caked with dust. Even the clouds above seemed dulled by the endless reflection of sunlight on that bright ruin. Weeks later, when merchant vessels had no choice but to cross the pumice, their hulls emerged scoured, paint stripped away by the ceaseless rasp of fine volcanic grit. Some captains described the sensation as running aground in open ocean. The sound, an unbroken whisper of abrasion, followed them long past the edge of the raft, a phantom friction that would not fade. And beneath it all, the sea remained warm, too warm. A slow cooling, measured in months, not days, as if the eruption's memory lingered in the deep, unwilling to let go. When the wind finally scattered the last of the floating stone, the surface gleamed again, a false return to normalcy. But anyone who had crossed that field knew the ocean would not forget what had passed. On shore, survivors described the day of the blast not by the shockwave or the darkness, but by the moment just before, the silence that fell so completely, it felt deliberate. Birds stopped calling, the wind stopped moving, even the surf paused, a long intake of breath that never seemed to end. Then came the roar, so vast it erased thought. People later tried to measure it in decibels, to compare it to bombs or thunder, or the engines of war, but the truth was simpler. The sound was beyond measure, something that bypassed the ears and vibrated straight through bone. Windows shattered 100 kilometers from the epicenter. Waves raced outward at the speed of memory, carrying not just force but a feeling, some deep recognition that the earth itself was not solid. In the hours that followed, radio operators on islands hundreds of miles apart described the same phenomena. Compass needles, spinning without cause, static roaring through the channels, the sky flickering with electric veins. For days, ash fell like a judgment, thin grey curtains soft as silk, but heavy with the weight of something older than any civilization watching. Children were born under that sky. Old men died waiting for dawn to break clean again. And when it finally did, the islands were changed forever, their outlines subtly rewritten by the waves, their histories divided into before and after the morning. The sea lifted the sky. In the weeks that followed, the Hunga Tonga eruption became legend. Scientists rushed to collect every fragment of data. Hydrophone recordings of the blast, echoing around the globe. Satellite photos, capturing the shockwave as a perfect ring expanding faster than sound. Measurements of waves that traveled thousands of kilometers before colliding with distant shores. But in the villages closest to the event, no one needed instruments to explain what had happened. They spoke of the sea rising into itself, of a brightness that filled the horizon, and left a silhouette burned behind their eyelids. Fishermen returned to harbours, buried in ash, their boats found half swallowed by pumice drifts, their engines choked by grit. Farmers unearthed fields, where nothing would sprout, soil salted by the ocean's incursion. The air itself felt thinner, a metallic dryness that lingered even after the rains. At night, the stars returned in full clarity, brighter than anyone remembered, and some said this was the ocean's apology, a glimpse of beauty offered in compensation for what it had taken. Yet every dawn brought the same awareness, that beneath the returning tides, Heat still pulsed, slow and hidden, reminding them that the eruption had not ended. It had only retreated, sinking back into the dark, to wait for the next moment to rise. Months passed, but the consequences of that single explosion unfolded like a chain without an end. Ships traveling the Pacific reported patches of water still stained brown with ash and pumice. Coral reefs near the blast zone died in waves of bleaching heat, their once luminous forests reduced to pale skeletons, even as scientists debated the eruption's place in the scale of geologic violence. The people who lived closest measured its impact differently. They counted missing boats, broken families, the strange taste of the wind. And beyond all this loss, there was the shape that now dominated the horizon, a new island, raw and black, steaming in the rain. Helicopters filmed it from above, a perfect crescent of hardened lava, barren, except for a few seabirds circling, as if in curiosity. The volcano had given something back, land where none had been. Yet, no one trusted it. Everyone knew it was not a gift but a reminder. Each time the waves broke against its shore, steam rose in silent columns, carrying the memory of the day the sea and sky became one. Children grew up watching that island, learning to measure distance by how its silhouette shifted in the morning haze. And though the scientists mapped it and named it, everyone else called it the same thing, the place the ocean chose to speak. Years later, when the eruption had passed from headline to history, its consequences still reached quietly across the Pacific. Researchers traced climate anomalies, brief coolings, subtle shifts in jet streams, to the countless tons of ash lofted into the stratosphere. Traders in distant ports recalled the strange weeks when cargo routes were disrupted, when harbors filled with floating stone and ship hulls emerged scoured raw. In Tonga, entire communities had been relocated, their villages rebuilt farther inland, their lives reoriented around the knowledge that the earth beneath their feet could change in an instant. Yet, for all the devastation, there was also a fierce, defiant memory of survival. Photographs taken days after the blast showed children playing atop drifts of pumice, as if it were snow, their laughter carrying across the ruin. In the dark weeks, when drinking water ran short, neighbors shared what little they had without question. And when the first crops returned, thin green shoots in blackened soil, they were greeted not just with relief, but with a gratitude deeper than words. Because the eruption had proven something fundamental, that nothing is secure, but life will insist on returning, again and again, even to a shore remade in fire. In the end, the Hunga Tonga eruption was more than an event. It became a kind of legend, a story woven into every conversation about the sea's power. For scientists, it was a data point without precedent. A blast so vast it circled the globe 4 times in pressure waves. A demonstration that the ocean's floor is not a place of quiet accumulation, but of sudden, catastrophic change. For the people who watched it happen, it was a moment when the familiar world became unrecognizable. Even now, when the sea lies calm, and the islands are green again, the memory of that roar remains. It is in the cautious glance seaward, when the horizon brightens too quickly, in the way old men pause before answering questions about where they were, when the sky turned black, and in the names given to newborn children, some carrying the word mafua, for eruption, as both a warning and a testament. Because to live near the ocean is to live in the knowledge that the past is never fully buried, that beneath the waves, the earth still stirs, breathing in silence, waiting for the moment it will rise again, and remind us how small we have always been. In November of 1963, a fisherman named Olafur paddled his trawler across the chill Atlantic waters, south of Iceland, scanning the grey horizon for any sign of squall. He had set out before dawn, engines purring beneath the hull, the sonar pinging its steady rhythm into the deep. There was nothing remarkable in the morning air, just the sullen weather of late autumn, and the hush that settled when a man was alone with the ocean. But as the light rose, he noticed a stain on the water ahead, a swirling discoloration that spread wider with each passing minute. It wasn't oil, It wasn't algae, it was darker, thicker, like ink bleeding upward from the seabed itself. He radioed the coast, voice taut, and turned his vessel in a cautious arc. Then as he watched, the sea began to heave, not with a wave or a swell, but with the bulge of something vast and rising. A single plume of steam burst from the surface, hissing into the dawn air, like a lung releasing centuries of breath. He felt the engine shudder underfoot. The water churned, and in that moment, Olafur understood that the world beneath his keel was not a still foundation. It was alive, and it was waking. Word of the eruption spread across the radio bands before noon. Reykjavik dispatched a reconnaissance flight, its silver fuselage gliding low over the coordinates where the ocean had ruptured. From the cockpit, the pilot saw a plume of ash coiling thousands of feet skyward, a black pillar torn through the bright Atlantic, shot through with red. The sea around the vent boiled like a cauldron, sending sheets of steam whipping across the waves. And in the center, a shape was forming. Not a shipwreck, not drifting rock. Land, an island clawing its way upward, grain by grain, from the seafloor's hidden fractures. As the pilot banked for another pass, the water split apart in a furious surge. Bombs of molten basalt erupted into the air, each fragment trailing a tail of fire before slamming into the waves. The sea hissed and swallowed them. A birth was unfolding, one so violent that even the sky retreated. Back on shore, scientists stared at the readings flooding their instruments, seismic tremors spiking, temperatures soaring, gas composition warping with sulfur and carbon. No one knew how long it would last. No one had ever seen an island born in real time, its body forging itself under a curtain of smoke. By the third day, the eruption was a spectacle. Columns of ash had risen more than 6 miles into the sky, drifting east on high-altitude winds and dusting fishing villages with grey snowfall. Ships maintained a wide perimeter, but the volcanic bombs still rained down, searing hot, hissing as they struck the water. The newborn island swelled, hour by hour, its black flanks steaming like the back of a submerged leviathan. Observers watched from a distance, binoculars trembling in their hands, as the vent widened further, spitting cinders in rhythmic bursts that sounded like some monstrous heartbeat. Icelandic geologists, their faces masked against the sulfur, described it as creation's raw engine laid bare. There was no myth in it, only physics. Magma forcing its way through fractures 2 miles deep, basalt boiling the ocean. Each blast was a sentence in an ancient language. The earth spoke only when the crust was torn open. In the village of Healy, children pressed their faces to school windows, staring at the dark cloud on the horizon. It was said that some elders refused to watch at all, that to see land rise from nothing was to glimpse something meant to remain hidden. On the 4th morning, a helicopter pilot, braving the turbulence, approached close enough to see the island's shape. It wasn't a flat smear anymore. It had shoulders, contours, a ridge rising along the vent's edge, where cooling rock began to cling together. Ash caked the rotor blades. Down below, the sea steamed in great circular patterns, heat radiating out like invisible scars across the waves. As the pilot hovered, he glimpsed something almost impossible. The moment a new coastline formed, a wall of spattering lava built up grain by grain, each piece fusing to the last, until a ridge stood clear above the waves. The surf clawed at it, breaking in white explosions of spray, but the land held. Over the next hours, the rim thickened, armoring itself against the Atlantic's erasure. This was not a temporary outpouring, it was a siege. The earth beneath Iceland was not content to remain below. It pressed upward in pulses that staggered the instruments, an exhalation that had begun eons before and would not stop simply because a few men in helicopters bore witness. As the eruption stabilized into a steady rhythm, research ships moved closer, instruments dangled on weighted cables, sampling the scalding water near the vent. Cameras rolled, capturing each fountain of molten rock as it arced against the sky. Geologists aboard the lead vessel worked around the clock, cataloguing gases, measuring pH, sketching the new contours that shifted with every tide. By the end of the first week, the island had grown to cover more than a square kilometre. It didn't yet have a name, but it had a presence, solid and undeniable. The ocean clawed at it constantly, hammering the new basalt with waves that sounded like artillery, but the eruption replenished it faster than erosion could consume. To watch it was to see the earth in a raw, unfinished state. No soil, no life, only incandescent rock forging itself into permanence. Each night, the glow of the vent turned the horizon red, a lighthouse of fire that pulsed through the darkness. The Icelandic government issued warnings for ships to stay clear, and yet no one could look away, because what began as a stain in the sea was becoming land, a place that would outlast them all. In Reykjavik's university laboratories, samples arrived by airlift, fragments of cooled lava, vials of sulfur-laced seawater, microscopic slides of volcanic ash. Each told part of the story, but none conveyed the immediacy of standing on deck, feeling the air change as the eruption roared. Reporters wrote of the smell, sulfur and salt, sweet rot, and the faint undertone of something metallic. The heat rolled across the waves, distorting the horizon. When the wind shifted, it carried a rain of black grit that stained everything it touched. To the scientists, the spectacle was a dream, proof that their theories of seafloor spreading and volcanic birth were true. To the fishermen whose roots threaded these waters, it was a warning. The sea was no more fixed than the sky, and something as simple as a morning's trawl could end in fire. The Coast Guard established patrols around the growing island, but each dawn, when the ash settled and the tide pulled back, the land remained. It was taller, broader, more resolute, as if the Atlantic itself had been forced to make room for this newborn outpost of stone. The island's name came on the 9th day. A geologist, exhausted and blinking through a crust of salt, proposed it with a dry voice over the radio: Surtsey. The island of Surt, the fire giant from Norse legend, whose burning sword would end the world. The name suited it. This black, smoking heap, clawing skyward. The news wires picked it up, and by afternoon, newspapers across Europe carried the headline, Surtsey Rises. To the outside world, it was a curiosity. To those who lived within sight of it, it was a thing alive. Fishermen recounted dreams of the island splitting open again, pouring rivers of flame that stretched to the horizon. Some refused to sail within miles of it, claiming the water itself felt changed, thicker, charged with something old. Scientists worked in relays to document the transformation. Each measurement, temperature, gas flux, seismic tremor, read like a confession that the earth was not inert, that the crust they called home was a skin stretched over hunger and heat, and that sometimes that hunger broke through. Through November, Surtsey grew faster than anyone dared predict. In less than 3 weeks, it had doubled in size again, a bulging crescent of lava and ash, rising above the grey North Atlantic. Pilots returning from survey flights described the island as a wound that refused to close. Each pass revealed new ridges and steaming fissures. Where the sea had swallowed yesterday's outflow, today's eruption reclaimed it. Even at a safe distance, the sound travelled, a constant muffled detonation that pressed against the ribcage and made speech feel trivial. By then, the eruption had developed a rhythm all its own, explosions every few minutes, steam jets erupting in white columns, curtains of black cinders falling in arcs. Aboard the nearest research vessel, crew members struggled to keep their instruments clean of the fine ash. It drifted into every crevice, coating decks, lodging in their hair, clinging to their clothes. At night, when the wind died, the glow of the eruption painted the underside of the clouds red. Some called it beautiful, others could not bring themselves to call it anything. It felt too much like watching something that never meant to be seen. When the first landing was proposed, many on the expedition argued it was too soon. The island was still raw, too unstable. But curiosity has always outweighed caution. On a morning when the eruption briefly waned, a small team boarded an inflatable craft and pushed through the steaming surf. The approach was harrowing. Waves smashed against half-cooled lava, sending plumes of hissing spray into the air. The men pulled the boat onto the black shore with gloved hands, boots sinking into warm grit. The ground was alive, vibrating with each subterranean tremor, radiating heat like the side of a kiln. One geologist knelt and pressed his palm to the crust, feeling it shiver beneath him. It was as if the island resented their presence. He recorded the temperature, far above boiling in places, and collected a chunk of basalt no larger than his fist. All around them, new vents spit sulphurous breath. No one stayed long. When they turned back toward the sea, one man paused, looking inland where fresh plumes rose. He would later say that for a moment, he was certain the land itself was breathing. Back aboard the ship, the men removed their helmets in silence. The samples were laid out on a tarp. Stones still too hot to hold, flecks of sulfur, chunks of half-cooled lava. None of it looked remarkable at first glance, but they knew they had witnessed something few ever would, land in the very instant of its making. On deck, they stripped off their protective suits, revealing sweat-soaked clothes. A medic checked them for burns. None spoke of the unease that clung to them. It was hard to admit aloud that the ground they had walked on hadn't felt finished, that it seemed to resent being touched. As the ship pulled back from the coastline, the island erupted again, huge fountains of rock, hurtling skyward, ash sweeping over the waves. The geologist who'd knelt on the shore stared back until the new smoke swallowed the ridge they had crossed. He felt for an instant that Surtsey had noticed them and decided to remind them who ruled the seam between ocean and sky. In Reykjavik, the newspapers sold out by noon. Photographs of Surtsey's birth, grainy and stark, filled the front pages. Children traced the island's outline with their fingers. Elders shook their heads and muttered old proverbs about fire giants and punishment for hubris. Scientists, meanwhile, crowded into conference rooms, pinning maps and graphs to walls already crowded with theories. Each day the readings arrived, tide charts, gas analyses, seismic records, offering glimpses of the colossal forces grinding beneath the Atlantic crust. Theories of plate tectonics, still young then, felt suddenly inadequate to capture the spectacle. It wasn't just geology, it was proof that the Earth itself could upend every assumption overnight. Outside the labs, fishermen returning to port told stories of strange tides and glowing water. They described the sensation of passing too near the island, pressure tightening across the chest, a metallic taste at the back of the throat. Some refused to cross those waters again. Others steered closer, unable to resist watching the sea be rewritten in real time. Surtsey's eruption became a kind of performance, terrifying and hypnotic. Ships came from distant ports to watch. Journalists arrived with cameras wrapped in plastic sheeting, their lenses fogging with volcanic steam. Every hour brought new convulsions, lava fountains surging hundreds of feet, thunderous detonations of gas and stone, waves crashing against walls of fresh basalt. Those who dared anchor nearby said the air itself felt heavier. A weight settled over the deck, a sense of trespass. To witness a world forming itself, molten and defiant, was to feel small in a way that no map or textbook could teach. On shore, villagers kept their radios tuned to the broadcasts. Even miles away, the sound reached them, a muffled rhythmic concussion, too deep to mistake for anything but eruption. Children dreamed of the island as something alive, something that would walk toward them when the last rock cooled. The scientists knew better. The island would remain fixed in place, but in the dark, with ash drifting like black snow, it was hard not to believe otherwise. December brought storms that tested Surtsey's claim to permanence. Atlantic gales pounded the new land relentlessly, clawing at its shorelines, tearing away any loose debris. For days at a time, the island vanished behind curtains of spray. Observers watched from ships anchored at safer distances, counting each time the surf overran the ridges. But the eruptions did not stop. Every wave that smashed the island was answered by a fresh outpouring of lava. Surtsey grew in defiance of the sea, In the brief lulls between tempests, aerial surveys showed the coastline reshaping itself, deltas of new stone bulging outward, caldera walls thickening against erosion. This was not the delicate balance of life eking out survival. It was brute assertion, the earth staking its claim in the open. For all the power of the Atlantic, it could not erase the island, and each week, the land grew higher, black cliffs bristling with fresh fractures, the sea below steaming like a cauldron. As winter deepened, scientists prepared for the eruption's eventual end, but Surtsey had no intention of finishing quickly. December turned to January, and still the plumes rose. Observers began to catalogue subtle changes, the texture of new lava flows, the frequency of explosions, the curious formations that emerged along the ridges. Steam vents appeared farther from the main crater, suggesting fractures spreading under the sea floor. One researcher described it as listening to a conversation you could not quite translate, patterns and signals hinting at something deeper. Ships came and went, rotating crews who measured, sampled, sketched, yet no matter how much data they gathered, the heart of Surtsey remained unknowable. It was a reminder that even in an age of instruments and satellite eyes, the planet still held secrets. Each dawn, the new coastline gleamed wet and dark under the pall of sulphur haze, and each night, the island glowed red in the darkness, the pulse of something that refused to yield. Months later, when the eruption finally began to slow, the sea tested Surtsey one last time. Storms hammered the coast, eating away at fragile promontories. Waves climbed the cliffs and swept newly cooled rock back into the deep. Yet the core held, the island, battered and blackened, remained anchored. In the spring thaw, the first gulls arrived. They circled overhead, cautious and curious, as though inspecting whether this creation was finished enough to accept them. Observers watched with quiet wonder as the birds settled on the warm rocks, their pale feathers stark against the scorched land. Life, always the final claim, had come to Surtsey. In the years that followed, seeds would drift in on wind and water, lichens would creep across the basalt, and scientists would chronicle every fragile foothold. But in those first quiet days after the last plume subsided, the island seemed to breathe again, not in fury, but in an exhausted calm. The sea sighed around it, as though acknowledging a new presence it could not erase. And for a moment, all those who witnessed it understood. They had watched the earth remember how to create. The sonar readouts first hinted at something stirring beneath the swells of the Solomon Sea, an ancient mouth in the ocean floor that had been known for decades by a name whispered between islanders and researchers alike: Kavachi. They called it the Volcano for the strange phosphorescent fish and sleek predators that gathered near its warm upwellings, as if the volcano itself exhaled something they needed. In May of 2022, the tremors grew more insistent, low rumbles registering in the hulls of passing vessels. The water above the caldera took on a peculiar haze, milky plumes rising like ghost smoke from the darkness. When the eruption finally breached the surface, it was as sudden as it was silent. One moment, an undisturbed blue stretching to the horizon. The next, an explosion of steam and rock, water slamming upward in a tower, so high that pilots flying routes between Honiara and Brisbane reported seeing the White Crown from 30,000 feet. Those who witnessed the blast from the decks of fishing boats spoke of a roar that didn't echo so much as it pressed down on their lungs, a force that made breath feel optional. Within hours, the sea turned grey. Rafts of pumice drifted out in lazy circles, heat still radiating from their porous skins. And beneath the surface, the craters of Kavachi remained unseen, continuing to boil in the dark, as if daring someone to come close enough to glimpse what it was building down there, hidden in the restless tectonic seams. The plumes that rose from Kavachi didn't dissipate like ordinary steam. They hung in the air, a sour mist that coated anything it touched, with a thin skin of sulfur and salt. Satellite images caught the concentric circles radiating outward, ripples of shockwave that traveled farther than any wave should have. Oceanographers scrambled to model the dispersal of debris, but the calculations kept shifting, because the volcano did not erupt once and rest. It pulsed. A rhythm emerged in the data, a sequence of surges every few hours, as though the caldera were breathing through layers of seawater and molten rock. By the third day, the eruption columns glowed faint orange at night, and the water closest to the vent turned acidic enough to corrode sensor housings. Still, the sharks came. Vast reported silhouettes moving just beyond the clouded perimeter, silvery outlines of hammerheads and silky sharks weaving in and out of the heated plumes. No one could say why they gathered there, only that they always had, as if some instinct older than fear drew them to the warmth and pressure. A few local fishermen said the sharks were guardians, circling the mouth of something that should never be disturbed. And even from miles away, the drifting haze felt like a warning, a message rising in sulfur breath: keep your distance. When the research vessel approached within a kilometer of Kavachi's main vent, the water under its keel shimmered with heat distortions. Instruments flickered and rebooted. The hull creaked as if some immense hand pressed upward from the abyss, testing the strength of the steel. Inside the lab, the team watched live feeds from submersibles lowered toward the crater's lip, their lights cutting through clouds of suspended ash and gas. Every few seconds, the cameras caught glimpses of something stranger than rock pillars forming along the vent walls, too uniform to be natural, almost like stalagmites molded by deliberate hands. Some believed they were mineral towers, layered from centuries of eruption, but others whispered that the formations looked arranged. As the sub drifted lower, one of the pilots swore he saw movement inside the largest spire, a flicker that wasn't turbulence but intention. Before he could adjust the thrusters, a surge of gas burst from the fissure, sending the drone spinning back into darkness. The feed dissolved into static, then silence. Hours later, when the winch hauled the machine back to the deck, its titanium casing was scored by fine parallel grooves. No one volunteered to send it down again. Days passed, but the volcano did not relent. Each fresh eruption stained the sea with a new color. Ochre one morning, bruised purple the next. Plumes of pumice drifted farther with each tide, carrying trapped heat that melted the barnacles clinging to their surfaces. The crew aboard the research vessel took samples whenever the sea calmed enough to allow it, measuring pH levels that dropped lower than any previously recorded in the region. Fish carcasses surfaced in slicks of grey scum, their gills seared by invisible acid. Yet, just as quickly, new life appeared, tiny shrimp and microbial mats, blooming in the warmth as if the destruction itself were fertile. Some scientists believed this was how oceans remade themselves, through violent resets that erased the old and seeded the new. Others weren't so sure. The patterns emerging in the eruption cycles seemed too methodical, the intervals too exact, as if something beneath the caldera was testing, adjusting, refining. No one said it aloud, but everyone felt it. Kavachi wasn't just venting pressure, it was announcing itself. As the eruptions continued into the second week, stories began to drift in from passing cargo ships. Crews claimed to see flashes under the waves, bursts of green light in the smoke, like phosphorescence magnified 100-fold. One captain reported that, during a midnight crossing, his vessel passed through a mile-wide slick of heated water where the sea glowed from below. The glow pulsed in rhythm, slow and patient, illuminating the shape of the hull as if studying it. When he ordered the engines to full power, the glow tracked them for 10 minutes, never brightening, never fading, before disappearing as if it had never been there. He refused to file a formal report. Mariners in these waters preferred their stories to remain unwritten. Still, the sightings multiplied. Each one described the same quiet detail, a presence in the plumes that never surfaced, never showed itself fully, but watched, like a mind built into the rock. And in the conference rooms where scientists gathered to plan the next observation run, no one was willing to laugh off the idea. By the time the eruption reached its third week, Kavachi had transformed the surrounding sea into a shifting wasteland of floating stone and chemical haze. Drones that ventured too close returned coated in a sticky film that corroded their housings within hours. The only consistent readings came from a buoy moored 5 miles from the crater. Every 12 hours, it transmitted a packet of data: temperature, acidity, seismic tremor. The graphs revealed a signature that had begun to repeat with uncanny precision. Pressure spikes rising and falling like a heartbeat. Even veteran volcanologists were unsettled. One compared it to the contractions of something preparing to give birth. Another suggested that the volcano might be nearing a larger rupture. At night, from the deck of the research ship, the plumes looked almost beautiful, columns of steam backlit by moonlight, ash swirling in slow motion. But no one watching felt calm. Every instinct said the same thing: Kavachi had more to say, and the next time it spoke, no one could guess whether the sea would survive the conversation. The scientists who stayed on station began to measure time differently, not by the hours marked on their watches, but by the intervals between eruptions, like counting the breath of something buried. Every roar from Kavachi seemed to change the character of the ocean around it. The surface would smooth to glassy stillness before each explosion, a hush so profound it made the heart pound. Then the sea would shudder, and a towering column of gas and steam would rip upward in slow, unstoppable force. When the plume collapsed back into the crater, waves would slap the hull in a rhythm almost musical. In the quiet that followed, you could feel the unspoken consensus among the crew. The volcano wasn't finished, it was thinking. One technician, unable to sleep, set up a microphone near the stern to record the underwater noises that never stopped. Listening through headphones, she described a constant background pulse, like the slow percussion of an enormous organ working in the dark. The longer she listened, the more she felt the sound was aware of her listening. She shut off the feed at dawn and never turned it back on. Even the wildlife seemed to sense something approaching. Seabirds that usually gathered above the plumes vanished for days at a time, leaving the sky vacant over the vent. Sharks that once circled boldly now kept their distance, skimming the outer edge of the sulfur blooms before sliding away into deeper water. One morning, a school of flying fish erupted in panic near the observation skiff, hurling themselves out of the water as though chased by something invisible. Their silver bodies struck the deck with dull thuds and flapped in blind terror until the crew threw them back. No one knew what they had seen. No sonar or camera caught any trace of a predator. But all day, the water remained strangely opaque, like the ocean was hiding its own reflection. By evening, the scientists logged the encounter as unexplained disturbance, but the entry sounded too clinical for what they all felt: that the volcano was drawing everything into a tension no instrument could quantify. A readiness in the water, thick enough to touch. In the third week, the eruptions briefly subsided, offering a window of deceptive calm. The research team took advantage, deploying a submersible to map the shape of the vent from close range. It descended slowly through layers of suspended ash, its lights glinting off floating pumice and streaks of sulfur yellow streaking the current. As the sub neared the caldera, its cameras revealed something few expected: new towers of rock rising along the crater's rim. They were smooth, almost cylindrical, as if extruded rather than formed by chaotic eruption. Some were taller than a man, spaced at regular intervals, in a pattern too precise to dismiss as coincidence. The pilot hovered in silence, scanning each formation with a mixture of curiosity and dread. When he tried to move in closer, a sudden upwelling of hot gas forced the sub backward, nearly toppling it into the vent. He managed to stabilize, but the incident was enough. They reeled the submersible home, and the video was stored in an archive that no one seemed eager to revisit. One of the geologists reviewed the footage alone, and later admitted she thought she saw something between the pillars, a shadow that didn't belong to any rock. When the seas grew rough again, it was almost a relief. The predictable violence of waves crashing over the deck seemed safer than the stillness that had settled before. At least storms made sense. But even in gale-force winds, Kavachi didn't pause. Plumes erupted through the whitecaps, hurling columns of superheated water skyward in bursts that made the horizon look fractured. The ship rolled so violently that equipment had to be chained to the floor. Yet each time an eruption struck, The instruments recorded something stranger than turbulence, a drop in ambient sound, as though the volcano pulled all noise into itself. For those listening over the hydrophones, the silence was worse than any roar, a void that pressed against the eardrums, heavy and expectant. When the sound returned, it came in a rush, like exhalation. One technician described it as listening to a lung that didn't need air. By dawn, when the storm eased, everyone on board was too exhausted to speculate what came next. But each of them knew they would remember that hush for the rest of their lives. The final week of observation brought a shift no one could have predicted. After a day of relative quiet, Kavachi began to erupt in a series of rapid-fire pulses, each blast sending shockwaves that rattled the hull like artillery. Between bursts, the sea seemed to steam rather than flow. Even the sky took on a pallor, an unnatural glare, as if the light itself were stained by sulfur. A drone flight over the vent showed a ring of fresh deposits growing outward, new land taking shape in real time. But it wasn't the expansion that troubled the scientists. It was the pattern, a near-perfect circle, forming in increments, each eruption adding to its edge, with methodical patience. No random violence, no haphazard layering, just a clean, deliberate architecture. When the drone returned, its heat sensors were warped, scorched by temperatures that should have been impossible at that depth. On the ship, no one could explain it. Some refused to try. They simply watched from the rails as the volcano continued its work, shaping something in the hidden dark that no tide would wash away. In the last days of the expedition, a strange resignation settled over the crew. The initial thrill of witnessing Kavachi's ferocity had given way to a quieter, almost reverent dread. Each eruption seemed less like a random convulsion and more like punctuation in an ongoing dialogue the volcano was having with itself. Early one morning, a final drone flight was launched to capture high-resolution imagery of the newly formed structures along the Caldera's rim. As the craft descended, the pilot narrated observations in a low voice. Black columns, radial cracks, concentric terraces cooling in the grey dawn. Then the feed flickered, just once, and came back. In that single frame of interruption, a shape hovered in the plume's shadow. No one could agree what it resembled. Some said a fin, some a wing, some only a trick of smoke and fractured light. But when the footage was scrubbed, the shape did not reappear. The only record was the memory of those few who'd seen it, and the hush that followed in the control room. The drone returned scorched and pitted, sensors melted from heat, so intense it exceeded design tolerances. The pilot refused to fly it again. He only said that Kavachi was finished showing them what it wanted them to see. On the last night, the ocean lay too still, as if exhausted by the weeks of upheaval. The horizon was a single unbroken line, dissolving into darkness that swallowed every light but the ship's own. The crew moved in quiet routines, logging data, securing cables, locking away samples no one would analyze for months. The lead geologist sat alone near the stern, listening through headphones to the hydrophone feed one last time. She closed her eyes, straining to detect any hint of the low pulsing she'd come to expect. But the volcano was silent. Just when she began to think it was over, a single deep vibration rolled through the headphones, a tone so low it felt more like an ache in the chest than a sound. It rose slowly, steady as a tide, before falling back into silence. She removed the headphones and pressed her palms flat to the table, as if to ground herself. The data logger showed nothing, no spike, no anomaly, no trace. But she would never forget the sensation that somewhere in the depths, Kavachi had released a final breath, the last word in a language no one on the surface could speak. At dawn, the ship's engines rumbled to life. The research window had closed, funding spent, weather turning, as the vessel pulled away. Everyone stood on deck for a final look. A thin column of steam drifted from the volcano, marking its position like a signal fire in a wilderness of salt. The new land ringed the vent in a pale crescent that hadn't existed when they arrived, proof that the sea could still be remade in days if something beneath decided to wake. In the logbook, the expedition leader wrote a closing note. "We came to measure heat and movement, We leave with questions about intention. No one disagreed. When the engines throttled up and the horizon began to swallow the last plume of steam, a few turned away quickly, unwilling to watch it disappear. The ocean closed over the memory of flame, as it always does, indifferent, serene, unchanged on the surface. But everyone aboard knew the truth. Kavachi was still down there, dreaming in the dark, patient as geology, ready to rise again when no one expected it. Long after the ship reached port, and the crew scattered to other projects, the images of Kavachi haunted their thoughts. Even months later, in quiet rooms far from any shore, some would wake at night, with the echo of that last vibration still in their bones. Reports were filed, papers written, footage catalogued, but no report captured what it felt like to stand above a volcano that remakes the map in silence, answering to nothing but its own slow purpose. The final charts showed a new island forming, a testament to the hidden architecture that shapes the world without witness. In time, the waves would erode it back to nothing, but the memory would remain, a reminder that the ocean floor is alive, that it dreams in eruptions and sings in tremors no human ear can hold for long. And perhaps in some deep fold of darkness, Kavachi remembers them too, the quiet figures who leaned over the rail, thinking they were only observers, the ones who dared to listen while the sea cracked open, and something older than history exhaled its fire into the waiting sky. The first time Axial Seamount erupted in living memory, no one saw it happen. There were no plumes breaching the waves, no columns of steam announcing the event to passing ships. The only witnesses were sensors buried in the sediment, and instruments bolted to the ridge's fractured flanks, machines built to listen to the Earth's slow breathing. It was April of 1998 when those instruments began their chorus, tremors rising in tight succession, pressure sensors dipping in synchrony, hydrophones catching vibrations like the low growl of a leviathan rolling over in sleep. But even then, the signals were nearly lost in the churn of background noise, the sigh of vent currents, the grind of basalt cracking against itself, the murmurs of distant whales whose songs wove through every recording. Only when the seafloor began to drop, meter by meter, did researchers realize that something vast was unfolding in silence. Axial Seamount is not a single mountain, but a bruised swelling in the Earth's crust, a caldera crowned by collapsed summits and fissures that spill molten rock in slow searing sheets. Unlike the sudden violence of a Surtsey or Hunga Tonga, Axial works patiently, like a clock unwinding beneath the North Pacific. Its eruptions rarely break the ocean's surface, but they transform everything hidden below, new lava plains stretching in darkness, hydrothermal vents blooming with chemical life that never glimpses the sun, and an architecture of fractures that migrates year by year across the ridge. It is a place where the planet reheats itself from the inside out, unseen by any human eye. The team that first mapped Axial's caldera in detail described it as standing on the roof of a vast cathedral. The walls sloped away into trenches so deep that lights were swallowed before they reached the floor. Even the submersible's high-intensity beams seemed feeble against that darkness. The pilot compared it to dropping flares into a canyon made of ink, and yet the instruments never faltered. As pressure gauges swung and seismographs trembled, the hidden seams in the crust began to open. Lava crept from fissures in slow curtains that cooled almost as fast as they emerged. In hours, the fresh rock sealed itself over again, hiding the evidence of upheaval beneath a crust that looked unchanged to any passing glance. In later years, as monitoring arrays multiplied across the caldera's flanks, scientists learned to predict Axial's cycles almost. Magma chambers refill steadily, inflating the summit like a bruise beneath the skin. Strain builds measurable as slow swelling of the seafloor, and when the burden grows too great, the chamber collapses in a sudden deflation, pushing lava through fractures that twist outward like veins. But knowing this never made it feel less alien. The pressure that cracked basalt under 4 kilometers of water was beyond any human scale, older than the ridge itself, part of a tectonic ballet that has no need for witnesses. In 2015, Axial erupted again, just as predicted, and again no one saw it. The proof came in lost instruments, pressure recorders that vanished into fresh flows, cables sheared where they crossed newborn fissures. A submersible sent weeks later found the seafloor transformed, smooth ropes of black rock stretching across what had been rubble, vents that had sealed forever, and new vents belching superheated water laced with minerals, potent enough to nurture entire ecosystems. Tiny crabs, blind and white, scuttled across lava still warm to the touch. The seafloor had remade itself while the surface world slept. Standing above Axial's hidden caldera, you feel the same unsettling perspective that haunted those first expeditions, that you are an intruder in a cycle that neither requires nor acknowledges your presence. The volcano does not care about names or measurements, or the fragile curiosity that drives ships across thousands of kilometers of empty sea. It is a slow machine, older than memory, shaping the crust beneath the Pacific Rim, without ever once needing to announce itself in flame. Those who spend their lives studying it sometimes admit, in unguarded moments, that they feel watched when the hydrophones begin to hum, as if something beneath the basalt recognizes them, just enough to wonder why they keep coming back to listen. When Axial Seamount erupts again, and it will, it may not trouble the surface with a single wave. No ships will feel the tremor, no satellites will glimpse its glow. But in the dark vault of the caldera, where black smokers dance with mineral-laden plumes and the crust of the planet tears itself open inch by inch, the record will be written in a language older than history. The lava will spread, the vents will bloom and die, and the ridge will remember, layer by layer, eruption by eruption, every moment when the deep cracked open to remind the sea above that the earth still dreams in fire. The first explorers who set their submersibles down on Axial's flanks never expected to feel the ground move beneath them. They were prepared for darkness, for the strange life that clings to the hydrothermal chimneys, for the eerie quiet that settles when the engines cut out. But they weren't prepared for the sensation that the mountain itself was breathing. The pilot logged the first tremor as a shudder in the seat. So slight, he thought it was the ship flexing under pressure. But then the tremor came again, longer, a low vibration through the soles of their boots. And for a moment, as the floodlights swept over fields of sulfur towers and fresh black basalt, it felt as if the volcano were alive in a way no instrument could ever quite capture. The Seamount's name doesn't hint at that hidden vitality. Axial is a reference to the ridge axis, a term of geology, not poetry. But the place itself has never been content to remain a diagram in a textbook. Under 4 kilometers of Pacific water, it behaves with the patient, relentless force of something ancient. You can measure its inflation, literally watch the seafloor rise over months as magma wells into hidden chambers. You can chart the inevitable deflation when the molten rock drains out into fissures that wind across the caldera floor. And you can see, time after time, the evidence that all this has happened before and will happen again. During one of the longest monitoring projects in submarine volcanology, researchers installed an array of tiltmeters, pressure gauges, and seismometers across the caldera's cracked surface. Each instrument was a fragile bead of technology, perched on a landscape that could erase it without warning. For years, the network kept watch. It listened to the small earthquakes, sometimes hundreds in a day, measured the slow swelling of the ground, and tried to predict when the volcano would decide to breathe out. The logs are a testament to patient observation, numbers ticking upward, then spiking without warning as the chamber reached its limit. The eruption came not with a single explosive convulsion, but with many lava seeping from fissures, layering fresh crust over the wreckage of older flows, until the vents were reborn in new places. Those who study Axial often talk about the way time changes when you're down there. Every second feels suspended. There is no wind, no daylight, no horizon, only the slow crawl of your lights across formations that could have been laid down yesterday or 1,000 years ago. The chimneys rise in impossible architecture, towers of minerals that look sculpted, filigreed columns dripping with sulfur and iron. Around them swarm creatures that don't need the sun. Blind shrimp and white crabs graze on bacterial mats that shimmer with chemical energy. Tube worms, red as fresh wounds, anchor themselves in vents that would scald any other life. Every eruption wipes them away, and every eruption they return. The team that piloted ROVs across the caldera floor after the 2015 eruption, described the strangeness of seeing old landmarks gone. Chimneys they'd named, formations they'd mapped in meticulous detail, simply vanished beneath fresh sheets of lava. What replaced them looked almost identical, ropes of black rock folded into the same patterns, vents opening in the same places, as if the volcano were rebuilding itself to a template no human hand had drawn. One researcher called it the memory of the mountain, a phrase that stuck long after the expedition ended. Because Axial does seem to remember, its patterns repeat, its fractures reappear. It's not random chaos, it's a ritual. And yet, for all that predictability, there are always surprises. In one sector of the caldera, sensors recorded temperature spikes weeks before any eruption. Another time, the lava burst up through vents miles from where the swelling had been measured. Once in 2011, the instruments simply went silent. No warning, no signal. When divers finally returned months later, they found the entire array buried under fresh basalt, perfectly entombed. The mountain had risen, split, and healed again, all without leaving a mark on the ocean surface. Above Axial, the Pacific seems unchanged. The swells roll over the ridge, without knowing or caring that the crust below has remade itself. The nearest ships rarely pause to consider the caldera under their keels. But if you were to listen, really listen, you'd hear it. Low tremors echoing through miles of water, a heartbeat as old as the ridge itself. A reminder that all the quiet expanses we think of as settled are just thin crust over molten patience. The scientists who return to Axial, year after year, know this better than anyone. They know that each descent into the caldera could end with them watching the ground open beneath them. They know the vents they catalogue could vanish overnight. And still they go back, because no other volcano on Earth offers such an unbroken record of the deep processes that shape the planet. Axial doesn't erupt for us. It doesn't erupt to be studied. It erupts because it must, in rhythms that will continue long after our observations are forgotten. When the next eruption comes, and it is never a question of if, only when, the seafloor will rise again, the pressure will peak, and the rock will crack open in darkness. Maybe the instruments will catch it in real time. Maybe they will be buried again, erased before the data can be transmitted. But whether we see it or not, the mountain will remember. The lava will trace the same fractures, build the same vents, and cool into the same silent formations. The creatures will return, the chimneys will grow, and the ridge will sleep until the next time the chamber fills. To stand on the summit of Axial Seamount, to look out over that silent, lightless landscape, is to glimpse a truth that no satellite or sonar map can ever fully capture. That even in the most ordinary stretches of the ocean, the Earth is alive, restless, and infinitely patient. And that in the slow fire beneath the Pacific, the world remakes itself over and over, as if reminding us that nothing we build, nothing we measure, will ever be as enduring as the seafloor rising to meet us. Long before satellites and submersibles traced Axial's contours, there were only rumors. Fishermen spoke of places where the water steamed without warning, where fish rose belly up in scalding tides, where the sea seemed to breathe heat. They could never pinpoint the cause, and no charts marked anything unusual. To the surface, the Pacific here looked like any other place, vast and indifferent. Only the occasional earthquake hinted that something moved far below. It was the invention of seafloor observatories that finally revealed the truth. Axial is among the most active volcanoes on the planet. Its eruptions don't announce themselves with plumes or fire. They begin in silence, miles beneath the waves, where magma collects in chambers hidden under layers of basalt. The process is slow. Months, sometimes years, pass as the seafloor swells like a bruise forming under skin. Instruments detect tiny changes in tilt, a millimeter at a time. The tension grows in darkness until the crust can no longer hold. Then, in a matter of hours, the fractures unzip. When the 2015 eruption began, no one on the surface felt it. But down in the caldera, the ground split open, and lava poured into fissures that had waited centuries to be filled. In the first hours, the molten rock surged across the caldera floor, drowning fields of vent chimneys, encasing sensors in cooling basalt, and remaking the landscape. But unlike eruptions on land, there was no roaring firestorm. The seawater above absorbed the heat in roiling clouds that never reached daylight. From orbit the eruption left no trace. The first ROV to descend afterward found everything transformed. What had been familiar territory, named vents, known formations, was gone. In their place stood fresh ropes of cooling lava, still warm to the probe's touch, steaming under pressure. New fissures had opened in perfect lines, each one a window into the magma, still pulsing below. The lights of the submersible caught ghostly columns of sulfur particles drifting upward. Even the water seemed unsettled, as if the eruption hadn't fully ended. In this world, life has learned to endure the cycles of destruction. Within months, tube worms reappeared, anchoring themselves to the still warm rock. Bacterial mats spread across the cooling flows, feeding on the minerals leaching from fresh fractures. Crabs returned, blind and unhurried, finding purchase on any ledge that wasn't too hot. To human eyes it looked like recovery, but down here it is simply continuation, a routine older than memory. One dive team recorded the eerie quiet of a newly opened vent. The opening glowed with faint orange light, the last breath of the eruption's heat. When they moved closer, the ROV's microphones captured a soft hiss, like steam escaping a kettle. But in the intervals between that noise, there were deeper sounds, pulses so low they vibrated in the pilot's chest. Not a roar or a crack, but a patient thumping, as though the volcano itself were exhaling in slow, measured intervals. In those moments, it becomes impossible to ignore that the entire caldera is alive. Not alive as animals are, but alive in the way a heart is alive, a system designed to beat, to contract and expand, to move energy in unstoppable cycles. Geologists have a word for the swelling that precedes eruption: inflation. A word that sounds harmless, almost gentle. But in Axial's case, inflation means that tens of millions of cubic meters of molten rock are lifting the seafloor by meters, and that sooner or later, it must be released. One of the most unsettling discoveries was that the inflation rate has been increasing over the last decades. Each eruption seems to rebuild the volcano a little faster. Each pause grows shorter. No one knows exactly why. Perhaps the magma supply beneath this stretch of ridge has quickened. Perhaps the crust here has been weakened by centuries of eruptions, and cannot contain the pressure as well as before. What is certain is that Axial is not growing tired. It is only getting more active. On the monitors of the Ocean Observatory's initiative, the live feed from the caldera flickers through days and nights without dawn. The vents glow in infrared, a soft red halo of heat. Sometimes for a moment, the cameras catch the drifting shadows of creatures passing through: shimmering eelpouts, pale shrimp, crabs with claws raised as if tasting the current. They look ghostly, suspended over fractures that exhale warm mineral-rich plumes. If you watch long enough, the scale of time shifts. A day feels like a heartbeat, a decade feels like a breath, and yet, for all its drama, Axial Seamount remains mostly hidden. Ships pass overhead with no sign of the slow fire beneath them. Research teams come and go, lowering instruments they know may not survive the next eruption. The volcano does not care. It will keep rising and falling as it always has, its slow rhythm indifferent to our curiosity. The pilots who have hovered over its fissures describe a strange sense of kinship, an understanding that the same forces shaping Axial have shaped every continent and ocean trench. What looks like devastation is also creation. What seems like erasure is renewal. The world doesn't end down here, it begins again and again. In the silence of the Juan de Fuca Ridge, you can almost hear that lesson, that nothing is permanent, that everything moves, even if it takes 1,000 years, and that the heat beneath our feet has never cooled, only waited. When the next eruption comes, and it will, the ocean will once more absorb the violence. The seafloor will crack, the lava will spread, and the mountain will rebuild itself as if the last eruption had never happened. And in that darkness, the slow memory of the Earth will continue, unbroken, unseen, and unstoppable. In the decades that scientists have watched Axial Seamount, they have learned to measure the volcano's heartbeat, by listening to the sea. Networks of hydrophones track the subtlest tremors, tiny earthquakes called microseisms, each one a whisper of magma rising toward the crust. Some days the signals come in flurries, dozens in an hour, like the volcano clearing its throat. Other times, weeks pass in near silence, as though the mountain is holding its breath. But no matter how long the quiet lasts, it never means the pressure has stopped building. One researcher once compared it to watching an animal sleep. Its slow, steady breathing, its occasional twitch of muscle, the sense that it could wake at any moment and remind you exactly how alive it still is. And when it does awaken, it does not announce itself with any spectacle that breaks the surface. There is no pillar of fire, no booming explosion to mark the event. Instead, the eruption begins far below, under a mile of water, in darkness too complete for human eyes. The first evidence comes as a bloom of warmth. Subtle, at first just a thin veil of water that reads a few degrees hotter on the instruments. Then, as lava pours from the fissures, the water near the seafloor surges to temperatures that can melt the plastic housings of sensors. Even in the crushing cold of the abyss, the eruption's heat is absolute. Cameras sent to film the flows often survive only minutes before their housings deform. The molten rock advances across the caldera floor, erasing what stood before. Yet, within weeks, life returns. Bacteria bloom in delicate white filaments, their colonies spreading across fresh basalt like frost. Crabs and shrimp recolonize the vents, seeking out the warmth and chemicals that make this place livable. In the shallows, such a process would take years. Down here, where the boundary between creation and destruction is as thin as a membrane, it takes days. It is a reminder that life is not fragile in this place. It is simply patient. The slow inflation of the seafloor has become so predictable that geologists now forecast Axial's eruptions almost like weather. The 2011 and 2015 events were anticipated with uncanny accuracy, predicted months in advance by tracking the rising tilt and swelling of the crust. This makes Axial Seamount unique. It is the only volcano on Earth whose eruptions can be reliably foreseen. But knowing when it will erupt has not made it less alien. For all the instruments and models, no one can say exactly what triggers the final breach. Some think it is just pressure. When the strain becomes intolerable, the rock must give way. Others suspect something more complex, a subtle cascade of fractures, like a zipper unfastening along fault lines that were always waiting to part. Whatever the cause, when the fissures open, magma doesn't simply spill out. It surges in pulses, each one a separate burst of force. In 2015, a network of pressure sensors captured this phenomenon in real time. The data showed the lava advancing in rhythmic waves, 3 hours of violent flow, followed by nearly an hour of stillness, then another surge. To watch the recordings is to feel the strangeness of it, the sense that the volcano is not simply erupting, but breathing. Exhale, pause, exhale again. The pressure changes are so sudden that even the water itself shudders. Observers aboard research ships sometimes hear deep booms transmitted up the cables tethered to seafloor stations, sound traveling faster and farther through salt water than through air. The noise is never loud enough to break the surface, but it echoes in the hull, a vibration you feel more than hear. And then, just as abruptly, it stops. The fractures seal under cooling basalt, the heat wanes, the vents shift from violent jets of sulfur to gentle wisps of mineral-laden smoke. From the outside, you would never know the ocean had hidden a firestorm. Divers and sub-pilots who have visited the caldera speak of a peculiar reverence. They describe the newly erupted flows as landscapes not yet claimed by time, surfaces so fresh they almost shimmer. The lava ropes are black and glassy, delicate enough to shatter under the submersible's skids, and rising from the cracks are columns of shimmering haze, fluids so hot they refract light into shifting mirages. In that haze, the scale of human presence collapses. You are small, temporary, tolerated. The volcano beneath you has seen more eruptions than humankind has recorded history. Sometimes, in the months after an eruption, researchers lower instruments to measure the heat still bleeding from fresh rock. The probes return with data that would incinerate a human body in seconds. And yet, Just centimeters away, the water is near freezing. The boundary between boiling and ice lies in a space no thicker than a palm. It is this contrast that defines axial Seamount, absolute forces balanced by thin margins, destruction met with immediate renewal. There is no final shape here, no finished state. Each eruption erases the traces of the last. Each pause rebuilds the landscape in forms no one will see until the next dive. Even the names given to vents and fissures are provisional, markers doomed to be buried or transformed by the volcano's next exhalation. In this way, Axial is less a mountain than a process, a memory unfolding through cycles no human lifespan can fully encompass. Those who study it know that the next eruption is not a question of if, but when. The sensors anchored along the Caldera are watching right now, translating the slow pressure into numbers we can understand. Each millimeter of uplift, each tremor recorded, is another heartbeat, another step toward the inevitable release. And when that moment comes, the ocean will absorb it all in silence. The only evidence will be the shifting currents, the trails of fresh lava cooling under the pressure of the sea, and the knowledge that once again, something ancient has stirred, not to destroy, simply to continue. Because axial Seamount does not care whether we are watching. It does not erupt to be witnessed. It erupts because it must. Because deep within the planet, there are forces that cannot be stilled, only postponed. Forces that shape every continent and every ocean trench. Forces that in the dark between eruptions, are never truly asleep. North of Grenada, where the blue of the Caribbean Sea begins to deepen into the sapphire trenches of the Atlantic, there is a place marked only by a name that sounds almost playful. Chimneys. It doesn't sound like it should be dangerous. Doesn't sound like the sort of place that could one day rearrange an entire stretch of ocean. But those who know this volcano don't mistake the lightness of the name for kindness. Chimneys is a volcano that prefers to speak in sudden, choking clouds of gas and heat. A submarine cone rising over 1,000 meters from the seafloor, its summit hidden just a few hundred feet beneath the waves, waiting for the next surge. The first known eruption was recorded in 1939, when a fisherman saw the sea boil and lift into a column of white vapor and ash. For miles, the water shimmered as if the sun itself were caught beneath it. Boats passing over the site felt an invisible hand drag them down. Water turned to foam, unable to support their weight. That eruption left a permanent caution in the minds of everyone who worked the trade routes and fishing grounds in this part of the Antilles. Unlike many volcanoes that slumber between cataclysmic events, Chimneys is restless. It erupts often, sometimes in small puffs of gas that barely breach the surface, sometimes in violent blasts that send plumes of steam 3,000 feet into the sky. The intervals between events can be as short as a few years or as long as a decade, but they always return. Because beneath this section of the Caribbean plate, magma is pressing upward in steady increments, seeking any fault, any weakness. And when it finds one, the volcano releases its stored force with a suddenness that defies prediction. The most unsettling aspect isn't just the risk of explosions or floating debris, it's the gas. Chimneys releases huge volumes of carbon dioxide and other volcanic gases that dissolve into the seawater, forming invisible clouds that rise unpredictably. To sail into one is to feel the ocean turn alien beneath you. Buoyancy disappears. The hull drops. The waves themselves seem to flatten into a thin, oily surface as the dissolved gas robs them of their power to lift. A vessel caught in that moment will founder in seconds, the water swallowing it without struggle, without warning. Local sailors have learned to watch the sea with an instinct sharpened by generations. Some describe a smell, a metallic tang in the air when the gases begin to accumulate. Others say you can see the difference in the water's sheen, a sudden dullness that moves like a living thing across the surface. Marine authorities have established exclusion zones around the volcano, and ships receive alerts when seismic monitors detect fresh tremors. But even with technology and vigilance, there is no certainty. Chimneys is too close, too active, too independent to ever be fully predicted. During the 2001 eruption, researchers stationed hydrophones along the volcano's flanks recorded the sound of the seabed cracking open. The audio, still archived in Caribbean observatory databases, plays like a slow heartbeat, then a low groan that builds into a violent percussive roar. When you listen to it, you can almost imagine the summit rising in the darkness, the sea lifting in a dome above it before splitting apart into a tower of boiling water and ash. In that moment, the difference between land and ocean vanishes. The volcano claims both. Divers, of course, never venture anywhere near the summit. Even when Kikimjeni appears quiet, the water above it is laced with unseen hazards. In some places, the temperature can spike 30 degrees in a sudden rolling surge. In others, the dissolved gases linger in pockets that can suffocate any diver before they have time to react. The only safe way to witness the summit is by remotely operated vehicle, but even that comes with risks. ROV pilots have described the uncanny calm, how the seafloor looks as if nothing has ever disturbed it, until a curtain of bubbles begins to seep from the cracks. The summit itself resembles a broken crown, a series of jagged ridges encircling the central vent. Between eruptions, the rim accumulates a thin veneer of life, colonies of tube worms, patches of microbial mats that feed on the chemicals leaking from below. But every time the volcano stirs, the life is erased. Each surge of lava and gas coats the summit in fresh layers of sulfur and basalt, burying everything in a new skin. There is a story told by an older generation of Grenadian sailors that the volcano once erupted so violently it created an island overnight, a cone of steaming rock that smoldered for weeks before the waves reclaimed it. Geologists have found evidence that this is no myth. The seafloor here is littered with remnants of such ephemeral landscapes, cones that rose into the daylight and then slipped back below the tide. Each time Kikimjeni erupts, there is a chance it will try again. Some researchers believe the volcano is approaching another phase of growth. The summit is rising, slowly but measurably, as magma chambers refill. Each year the instruments show incremental uplift, centimeters of change that seem trivial until you remember that such small increments are what lead eventually to events that rewrite the maps. And if one day the volcano does erupt with the same ferocity as in the past, it may birth another temporary island, an arc of black rock that steams in the Caribbean sun. But no matter how tall it grows, the waves will take it back in time. That is the nature of Kikimjeni, to rise, to vanish, to remind everyone who watches that the seafloor is never still, never conquered, never ours. Even in its quietest seasons, the volcano waits. It listens to the shifting weight of water and the tides that stroke its summit. It builds pressure grain by grain, heartbeat by heartbeat. And when the time comes, it will erupt as it always has, indifferent to the ships above, to the stories told, to the names etched on charts. It will do what all volcanoes must do. It will remind us that the world beneath the waves is neither dormant nor tame, it is alive, and it remembers. In the archives of the University of the West Indies, there is a ledger of all the known eruptions of Kikimjeni, a ledger that grows longer each decade. The first entries are spare, almost casual, fishermen's reports of water that hissed and boiled, coastal rumors of thunder on windless days, and then, as the 20th century advanced, the notes turned clinical seismograph readings, bathymetric profiles, gas composition charts. But no matter how precise the data, it never softened the reality. Every entry in that ledger marks a day when the seafloor opened, when something deeper than memory rose and reshaped the sea above. To read those pages is to feel a quiet dread, because you realize that no matter how many buoys we anchor, or how many satellites we watch, Kikimjeni will erupt again, and the eruption will happen on its own terms. When the volcano rumbles, the first sign on the surface isn't always obvious. Sometimes it begins with a slow swell, a circular dome of water lifting over the summit as gases and magma accumulate. Sailors who have witnessed this say the sea looks almost solid, a taut skin reflecting the sky in a way that feels unnatural. Then, without any fanfare, the dome can burst, sending geysers of vapor into the air. In the 1939 event, witnesses described a roar that reached the mainland, an echo so deep it rattled windows along the northern coast of Grenada. At the eruption's center, the ocean foamed white, transforming into a vast whirlpool of gas-churned water. Anything afloat was in danger. Ships have vanished here, with only splintered planks or lifeboats recovered days later. It doesn't take much. A single inhalation of CO2 heavy air can suffocate a crew. A single moment adrift over the vent can pull a hull down in a heartbeat. During later surveys, researchers discovered debris fields scattered miles away from the summit, chunks of basalt that had been hurled outward by the force of the eruption, settling in tidy arcs like thrown dice. Some of those fragments weighed more than a car, others were no larger than a fist. But all of them told the same story, that Kikimjeni does not erupt in isolation. It leaves its mark across the Caribbean floor, a record etched in stone for anyone willing to look. There is an unspoken understanding among the shipping companies, whose routes thread through the Grenadines. No shortcuts over the volcano. Even when weather is clear, even when the sea is as flat as glass, there is always the chance of an invisible hazard. A sudden release of gas, a surge of heat, a shiver in the water that means the volcano is stirring, so the captains give it distance. They set their courses in wide arcs around the exclusion zone, mindful that the price of impatience is final. Yet despite the danger, Kikimjeni also exerts a fascination. Scientists come here to study how volcanoes evolve under pressure and conceal their violence beneath kilometers of water. Hydrothermal vents around the summit support life forms found nowhere else in the Caribbean, tube worms and crustaceans that thrive on sulfur and heat. Each eruption deposits fresh layers of mineral across the seabed, recharging the ecosystem with nutrients. The same violence that threatens ships also sustains a web of life no human hand can replicate. The volcano's summit is not a single point but a complex ring of fissures and secondary cones. RAVOs have traced cracks spiraling away from the central vent like the petals of some dark flower. From these cracks gas seeps in slow plumes that never stop. Even when the volcano is quiet, it exhales. The sea here is never quite still. During a survey dive in the late 1990s, researchers sent a probe into one of the fractures. The camera recorded walls coated in pale microbial mats, life forms that survive on hydrogen sulfide, indifferent to light and oxygen. The deeper the probe descended, the darker the rock became until it vanished into a slit so narrow no machine could follow. And though the camera went no further, the sensors kept recording the warmth rising from depths unseen. It's believed that Kikimjeni sits on the edge of a much larger magma system, one that connects to other volcanoes along the Lesser Antilles arc. When the volcano erupts, it is merely the most visible symptom of forces threading the crust beneath the entire region. Like a pressure valve opening for a moment before sealing shut again, each blast releases stress, but it also recharges the system, preparing for whatever comes next. One oceanographer, after a long expedition here, described the volcano as a heartbeat, steady, necessary, relentless. You could monitor its tremors, chart its outgassing, model its likely scenarios, but you could never silence it. It was a pulse, and it would continue to beat long after anyone alive today was gone. The local legends are older than the science. Some say the volcano is a guardian, an angry spirit that rises whenever the living forget to respect the sea. Others believe it's a mouth that occasionally remembers to speak, and when it does, the ocean listens. No story ends with the volcano resting in peace. It only ever waits. Every time a buoy drifts over the summit, every time an instrument line is lowered to take a reading, there is a pause. An unspoken question. Because everyone who studies Kikimjeni knows that the surface can lie, that beneath the calmest water in the Caribbean, an old heat is always coiling toward release. It is a place where the line between life and destruction is drawn thinner than anywhere else in the region, where invisible gases can take your breath before you feel them, where heat can erupt through 1,000 feet of water as if the ocean were no more than a veil, and where even in the darkness, something is always rising. The history of Kikimjeni is punctuated by intervals of quiet that never last. After the violent 1939 eruption, decades passed in which the volcano seemed to sleep. Fishermen crept back into the exclusion zone, emboldened by calm seas. Cargo ships cut across the charted danger area to shave hours from their routes. The Caribbean sun glittered over the same coordinates, where, just years before, the water had risen in a seething dome and burst, and for a while, the volcano held its peace. But in the 1980s, it returned with new purpose. Instruments anchored in the deep began to pick up seismic signals, tiny tremors that sounded like the distant grinding of old machinery. The signals multiplied, deepening into harmonic quakes that suggested magma was moving. Crews aboard the University of the West Indies survey vessels heard the sounds through their hulls, low droning vibrations that made the metal resonate like a struck bell. Some described it as a kind of warning, one that was patient but insistent. When the eruption finally came, it did so without spectacle, no towering plume, no earthquakes felt on the islands. Just a sudden upwelling of gas that killed every fish in the water for miles. Boats motoring across what looked like a harmless patch of ocean stalled as invisible CO2 blanketed the surface. The crews survived only because the gas dissipated on the wind, leaving behind a sea littered with the pale bellies of fish that had suffocated before they could flee. For the scientists studying the event, it was a brutal reminder that most of the volcano's power is invisible. The Caribbean holds its violence behind curtains of pressure and current, revealing it only in aftermath. The fish kills were mapped by helicopter, ragged white patches drifting slowly toward shore. In lab reports, the incident read clinically, mass mortality event, attributed to subsea gas release. But the divers who swam through the aftermath described something else, an ocean that felt hollow, as if life itself had retreated. It's this unpredictability that makes Kikimjeni more than a geological curiosity. Unlike surface volcanoes, it cannot be monitored with satellite thermal cameras. Its eruptions leave no columns of ash to betray their size. The only signals are the ones that happen far below human senses: a pressure pulse in the water, a rise in dissolved carbon dioxide, a slight bulge in the seafloor that no one will see unless they are looking precisely when it happens. Modern expeditions use an array of instruments to try to keep watch: hydrophones, gas samplers, multi-beam sonar. But even with all that technology, the volcano's behavior remains elusive. A survey may find a smooth crater rim 1 month, only to return weeks later and find the entire summit reshaped by a fresh eruption. In 2003, such a blast raised a new cone over 100 meters high, a newborn mountain that didn't exist on any chart. For the few days it was measured, it looked as permanent as any island. Then it collapsed back into the depths, leaving only a plume of sediment in its place. The Caribbean seafloor here is a landscape in constant revision. Every eruption writes a fresh chapter, then erases part of it before the ink can dry. Submersible pilots have filmed the vents at times when no eruption was underway, and even then, the sea was restless. Superheated water oozed from cracks like breath escaping an unseen throat. The sand around the vents quivered with escaping gas. In the ROV lights, it looked almost alive, an organism made of rock and pressure, testing the limits of its prison. Local stories about Kikimjeni are filled with the language of respect. Old captains will tell you the volcano is not evil, just hungry. A thing with no memory or conscience. But in quieter moments they admit that it sometimes feels personal, like the volcano chooses its moments with the cunning of something that watches from below. More than once, a ship has vanished over its summit on a day when no eruption was forecast, no warning given. In 2015, another surge of seismic activity forced authorities to expand the exclusion zone around the volcano. The instruments began to pick up hundreds of tiny earthquakes, each one a whisper in the darkness, impossible to feel on land, but clear to the sensitive seafloor sensors. The earthquakes came in swarms, then fell silent, then returned with double the intensity. For 2 weeks, the volcano held its breath, and every ship in the region diverted course. Then just as suddenly, the activity subsided. Nothing rose to the surface, nothing erupted. Kikimjeni had decided, for reasons no one could decipher, to wait. Some scientists think that beneath the volcano's visible crater lies a much larger reservoir of magma, an unseen chamber that feeds each eruption in unpredictable cycles. If true, it means the entire Grenadine Basin may be shaped over millennia by the pulses of this single vent. What we call an eruption is merely the smallest fraction of the system, a safety valve venting pressure so that the deeper chambers can continue to evolve. When you study Kikimjeni long enough, you come to understand that it is less a place than a process. It does not erupt to destroy. It erupts because it must. Because somewhere beneath the Caribbean plate, heat and pressure are always on the move. Because the ocean floor is not a static place but a canvas scraped and rewritten with every generation. On a calm day, the water over the volcano looks no different from the rest of the sea, a blank expanse reflecting clouds. But if you wait long enough, you'll see it. A faint swirl of bubbles breaking the surface, a shimmer of distortion as rising gas bends the light. The barest hint that something is awake beneath you. It is in those moments when the ocean forgets to hide its breathing, that you feel how thin the crust of the world really is, how easily it can crack, and how a volcano named for a local legend can remind you that all the charts and buoys in the world are only temporary. Because under the keel of every ship, the Caribbean is always watching, and someday, soon Kikimjeni will speak again. There have been nights in Grenada when fishermen swear they heard it, like distant cannon fire rolling up through their nets. They would look out into the dark toward the open water where no ship's lights burned, and feel something deep under the hull, as though the sea itself was lifting in one long, shuddering breath. That is Kikimjeni's signature. The volcano doesn't simply erupt. It announces itself. Even when no eruption breaks the waves, pressure rolls out in slow pulses, displacing entire sections of ocean in a force you can't see, but can feel in your chest. For years, scientists tried to measure these subtle shifts. In the early 2000s, hydrophones deployed around the volcano's slopes picked up rhythmic sounds, bursts of low-frequency tremors that continued for hours at a time, like a great engine turning somewhere far below. The readings weren't always consistent. Some weeks, the volcano would fall silent. Others, the sensors would pick up harmonic tremors that hinted magma was moving again, just beneath the summit's crust. And still, fishermen reported odd things, nets rising as if tugged by invisible hands, schools of fish scattering in unison, bubbles breaking the surface with no clear origin. When Kikimjeni did erupt, briefly violently, it hurled ash and pumice into the water, darkening the sea for miles. Ships were warned away. Underwater landslides reshaped the Caldera's rim, sending plumes of debris drifting across the seabed. The eruptions didn't last long, but their aftermath lingered. Water temperatures around the summit stayed high for weeks. Sulfur stained the currents yellow-green, and every new survey found subtle changes in the crater's shape, as if the volcano was slowly exhaling parts of itself in increments too small to register as disaster, but too constant to ignore. The threat wasn't just the eruptions. The real fear was the possibility that one day, the Caldera wall would fail entirely, collapsing in a single moment, and sending a tsunami barreling toward Grenada's shore. Models varied wildly. Some predicted waves only a few meters high. Others imagined a wall of water racing toward the coast, swallowing harbors and villages in minutes. Each new study added another layer of tension to the question of what Kikimjeni was ultimately building toward. Whether these small outbursts were only preludes, or whether the volcano was content to remain an undersea curiosity, dangerous, but never quite catastrophic. In recent years, the monitoring network has expanded: more hydrophones, more seismometers, more eyes fixed on the restless mound. Yet for all the equipment and all the data, the volcano remains stubbornly opaque. Even now, its rhythms refuse to follow any predictable pattern. A month of quiet can end with a single tremor that shakes the instruments and then fades to nothing. An apparent swarm of earthquakes can yield no eruption at all. And in the villages along Grenada's coast, people still glance toward the horizon when the water runs too still, wondering if the next warning will be another false alarm, or the moment when the mountain finally stops holding back. The Caribbean holds many legends about the sea, but none carry quite the same quiet dread as Kikimjeni. It's not the biggest volcano, nor the most active, but it is a reminder that the earth beneath the waves is not finished with its work, that the ocean floor is alive in ways we still can't fully measure, and that some of the forces moving under the keel of a passing boat are older and less patient than any story we tell about them. One day, the summit may finally rise into daylight, an island born in smoke and fear, or it may remain hidden, its eruptions confined to the dark. Either way, Kikimjeni is not done. Each tremor, each pulse of gas, each unaccountable swirl of warm current is proof that somewhere below the threshold of human certainty, something vast and indifferent is still building itself in the dark. Low-He Seamount sits southeast of the big island of Hawaii, a submerged mountain no island has yet claimed. On sonar, it rises like a shadow, 3,000 meters of slope and ridge, forming a summit that still waits nearly a kilometer beneath the waves. To look at it now is to look into a future not yet arrived. For Low-He is young by volcanic standards, a child of the hotspot that has already built Mauna Loa, Kilauea, and the great shields before them. One day, if centuries align in the quiet labor of lava, Low-He will become Hawaii's newest island, shouldering itself above the waves, in a birth that may span lifetimes. But even unseen, it is alive. For decades, research submersibles have glided over its slopes, recording the subtle tremors and fierce outbursts of a volcano that behaves more like a restless animal than a patient reef. The first clear evidence of its emergence came in the late 20th century, when swarms of earthquakes clustered around its summit. Each quake was small but insistent, a Morse code of shifting magma chambers pressing upward. In 1996, Low-He erupted in earnest. The summit vented superheated gas and debris, reshaping its shallow crater, Pele's Pit. Sensors placed around the caldera recorded temperatures so high that they exceeded instrument tolerances. Hydrothermal vents boiled the sea, staining the water with iron and sulfur clouds that drifted for miles. It was a warning. Low-He was not content to sit quietly beneath the waves. It would claim its place on the map in its own time, through a process older than the islands themselves. Each eruption deepens its summit pit, building flanks with fresh basalt and draping the slopes with the chemical signatures of new land. And each quiet period is only an intermission. The magma chamber pulses with pressures no instrument can fully map. Subtle bulges grow and recede in the rock. The seamount is learning how to rise, one tremor at a time. Scientists from Hawaii's volcanology community have come to regard Low-He with a mix of caution and fascination. In a region already dominated by active volcanoes, it represents a glimpse of beginnings, a window into how a mountain becomes an island. Submersibles that descend into Pele's Pit report a landscape unlike any other in Hawaii. Chimneys spouting scalding plumes, bacteria colonies flourishing in the darkness, fields of collapsed lava pillars, still warm to the touch. It is a place of raw creation, stripped of the illusions of permanence. Fishermen, too, have stories of Low-He, not myths, observations. Waters around the seamount sometimes run hot and metallic, carrying a taste no catch can hide. Sonar pings return strange echoes from the summit, and at certain times of year, small quakes ripple outward, rocking boats anchored far above. The old navigators once called such places the unborn islands, reminders that the sea floor itself was neither finished nor fixed. Each survey returns to the same question: when will Low-He breach the surface? No one can say. It could be 10,000 years or 100,000. But the process is inevitable. The hotspot will continue feeding its magma chambers. The summit will rise, collapse and rebuild, adding layer upon layer of basalt. And eventually the Pacific will give way to a newborn coastline, black rock steaming in salt wind, an island unclaimed by any flag, fresh from the furnace below. In this knowledge is both wonder and humility, because to stand on Hawaii's shores and look south is to understand that the land beneath your feet is only borrowed from deeper fires, and that somewhere under the silent miles of open ocean, Low-He is already building the future, one unseen eruption at a time. Long before the instruments marked its slopes, Low-He was already stirring in the darkness. Geologists studying the Hawaiian chain have pieced together its birth from fragments, layers of pillow basalt, mineral deposits, and chemical gradients that map a slow ascent from the mantle plume that has shaped this entire archipelago. Unlike the older islands, whose flanks sprawl above the sea in grand arcs of green and lava, Loei remains hidden in perpetual twilight. It is neither reef nor island, but an unfinished chapter, a place where beginnings are still unfolding. The first attempts to chart it were cautious affairs. Early sonar mapping in the 1950s hinted at an elevation rising off the abyssal plain, but the contours were vague, only a ghost shape in the data. As technology advanced, the seamount resolved itself into something more formidable, a structure as tall as Mauna Kea is above sea level, except submerged in pressures that would crush any unshielded vessel. Those first clear images of Pele's Pit, the collapsed summit Caldera, revealed a site of continuous activity. Even in repose, Loei releases gas and heat, streams of carbon dioxide, hydrogen sulfide, and the chemical gradients that sustain entire ecosystems in darkness. It's the life that surprises many. Around the vents, bacterial mats bloom in pale threads, feeding on the minerals rising from fractures. Colonies of shrimp and limpets cluster on warm outflows. Some of these organisms exist nowhere else, specialists in a niche that has never seen sunlight. To observe them is to glimpse an echo of Earth's earliest oceans, when volcanic warmth was life's only shelter. This fragile world persists in a place that could erupt again without warning. Each survey carries the risk of sudden violence. Submersibles have recorded moments when the sea shivers, not from earthquake, but from pressure, the magma shifting just below the crust. A quiet reminder that this landscape is alive in a way that defies comfort. Loei's eruptions leave scars easy to trace. Fresh basalt ridges, sudden collapses that deepen Pele's Pit, and trails of new vents that pockmark the summit flanks. Each outburst resets the local ecosystem, burying older life in sheets of cooling lava. Yet within months, extremophile colonies return, claiming their place among the fumaroles. It is as though the seamount teaches the same lesson over and over: creation and destruction are not opposites but partners. Hawaiian elders speak of fire spirits that dwell beneath the sea, restless forces that shape the islands one eruption at a time. In a culture where land and story intertwine, Loei is not just a curiosity, it is an ancestor in the making. Someday, when it finally lifts above the waves, it will inherit all the names and traditions that connect people to the volcanoes that birthed them. That thought lends gravity to every expedition. Each dive is a record of the island before it is born. To stand on the research vessels above Loei is to feel distance collapse. The horizon seems endless, yet beneath the hull, the mountain waits. Pilots describe moments when sonar pulses catch something moving, gas blooms drifting up like phantom clouds, or the outline of new fractures opening along the caldera. Instruments measure the rise and fall of the summit, breathing in cycles that last decades. Every tremor, every surge of heat is a heartbeat in slow motion. There are no guides for watching an island be born, no rules that dictate how humans should witness the patience of geology. All anyone can do is document the transformation, knowing it will outlast them by millennia. The basalt flows that coat Loei's flanks are fresh scars now, but someday they will be cliffs and beaches. The vents will cool, the bacteria will recede. What remains will be a new land where rain falls for the first time, carving gullies in virgin rock. Even now, Loei is not quite separate from the islands above. Its eruptions can stir seismic activity on the Big Island. Its hot plumes carry nutrients that enrich fisheries miles away. In that way, it is already part of Hawaii's living system, a submerged sibling that shares in the cycles of creation and decay. And when the time comes, it will rise to meet the sky with the same quiet inevitability that has shaped the Pacific Rim for tens of millions of years. To watch Loei is to witness a story far older than any record, one that will continue long after every ship and sensor has vanished. The sea does not care for our impatience, it only knows how to build. In the stillness above Loei, research crews often find themselves listening to the sea, as though it might answer. The sounds that drift up through the water column, Distant cracks, soft rumblings, faint murmurs of gas escaping, are reminders that this mountain is no less alive for being hidden. Unlike the violent paroxysms of other volcanoes, Loihi's movements often unfold in slow, patient increments. A flank expands by a few centimeters, a vent opens and bleeds heat. A ridge lifts its crown closer to the surface by the width of a human hand. Yet, there have been moments when that patience fractures. In 1996, an eruption began without preamble, announcing itself only by the sudden shudder of seismometers across the Hawaiian Islands. Instruments recorded more than 4,000 earthquakes over the next few weeks, some strong enough to rattle windows on shore. The summit Caldera collapsed inward, creating a new pit over 300 meters deep. For days, no one could approach safely. The ocean above boiled with expelled gas and suspended debris, a milky turbulence that seemed to churn with intention. When the first submersible returned to the summit, it was like descending into a new world. Fresh rock lay in jumbled heaps where the caldera had caved. Scalding vents hissed into darkness. A curtain of sulfur crystals drifted across the cameras in shimmering gold. Some of the life that had colonized the old vents was gone, smothered or incinerated. But already, new bacteria were blooming in thin filamentous mats. The team who piloted that dive described a profound sense of humility, as if the Seamount itself had reminded them of the scale on which it operates. What had taken decades to grow could be wiped clean in a single night. Even in repose, Loihi exerts a gravitational pull on the imagination. Few other places so vividly embody the idea that the Earth is unfinished, that the crust beneath our feet is merely a temporary shape over something in constant motion. Some scientists believe Loihi will surface within 10,000 years, perhaps sooner if eruptions accelerate. To consider that timeline is to feel our own sense of time shrink to insignificance. Human civilizations have risen and fallen in less time than it will take this volcano to lift its summit above the waves. The idea that this quiet mountain is simply biding its time makes every expedition feel like an intrusion into something sacred. Over the years, instruments have mapped dozens of hydrothermal vents, each exhaling chemical gradients that sustain ecosystems unique to this hidden slope. Certain species of shrimp are known only here, adapted to the mineral-rich plumes that nourish them. Pale eelpouts drift among sulfur spires. Microbes create delicate mineral filaments that tangle into colonies unlike anything on land. In these communities, life is anchored not by sunlight but by the restless generosity of the planet itself. Each new eruption obliterates some of this fragile network, only for it to bloom again, proof that even destruction has its place in the long story of creation. The stories of Loihi are not all told by machines. Native Hawaiian traditions speak of the fire goddess Pele and her migrations across the islands. In this cosmology, volcanoes are not inert piles of stone but living relatives. To stand over Loihi, even on a steel research vessel, is to occupy the threshold between science and story. Here, observation and reverence coexist. Here, every measurement carries an unspoken acknowledgement of something older and vaster than any record. During long nights on station, the ship's crew often gather on deck, watching the blank face of the ocean. Even when all instruments are quiet, they say you can feel Loihi's presence. It rises in the salt-heavy air, a tension you can sense in your chest, as though some immense shape below is considering you. Some claim they hear low tremors vibrating up through the hull, a steady rhythm that feels too deliberate to dismiss as current or engine noise. No one ever agrees on what the mountain is saying, only that it has a voice, patient and untranslatable. On rare clear days, when the Pacific smooths to a perfect mirror, the idea that an island waits below becomes harder to hold. The surface gives nothing away. But drop a hydrophone, and the quiet breaks, pops and hisses. The slow churn of thermal vents, the whisper of rock shifting against rock. It is a reminder that Loihi's story is being written even now. Each earthquake and eruption a sentence in a language without words. Someday that story will break the surface. Waves will meet fresh basalt, and the first rains will carve gullies in cooling lava. Seabirds will circle, finding purchase on land no creature has ever touched. What seems so remote today will become a visible presence on the horizon, an island with a name and a place in maps, though it will always belong first to the ocean that raised it. For now, Loihi remains hidden. But its growth is inexorable. It waits, patient and steady, a promise of change sealed beneath the weight of the Pacific. And those who come here to listen leave with the same impression, the sense that time itself is deeper here, pulled down by the slow rising of a mountain that remembers every moment of its becoming. When you think about the birth of an island, it's easy to picture fire and violence, a cataclysmic breach of magma, exploding into the sky. But low sea doesn't often declare itself in spectacular displays. More often, it whispers its intentions in quiet tremors, in chemical plumes, in the incremental heaving of its slopes. The story of this seamount is one of steady accumulation, eruption by eruption, fracture by fracture, each event adding another layer to a future coastline. None of us will live to see. This knowledge shapes every expedition. When scientists deploy submersibles here, they do so with the understanding that the landscape may already have shifted since their last dive. The seafloor vents mapped years ago might be buried now. The ridges that once towered above the Caldera rim may have collapsed, replaced by fresh mounds of pillow lava. Even the bathymetry itself, painstakingly charted in dense sonar grids, carries the quiet caveat that tomorrow it could all be different. Low sea does not wait for us to keep up. One dive in 1996 remains among the most vivid ever recorded here. The rove descended through silt, so thick it resembled smoke, stirred by the collapse of the summit pit. Visibility dropped to mere centimeters. The operators in the control room watched the screens as if trying to read through a blizzard. And then, as the silt parted for a moment, the camera caught a glimpse of something that felt impossible: incandescent rock still cooling, glowing in deep reds and oranges, even under the crushing pressure of a kilometer of seawater. For that instant, it was as if the crust of the earth had cracked open to show the molten secret inside. The image haunted every member of the team. Many said later they dreamed of that glow, something both terrible and beautiful, alive in a way no laboratory instrument could ever quantify. It is perhaps this quality, this reminder that the earth is alive, that makes low sea more unsettling than volcanoes we can see. To walk across Kilo Sea is to feel the heat underfoot and smell the sulfur in the wind. But to drift above low sea is to know that the same forces are at work out of sight, rising in total darkness, building something vast beneath the indifferent expanse of the Pacific. The weight of that hidden process can feel personal, as if you are trespassing in a place that hasn't decided yet whether you belong. Every time a new vent opens along low sea's rift zones, the ocean answers. Superheated fluids pour into the water column, carrying dissolved minerals that shimmer like suspended stars. Bacteria colonize the fresh lava within days, forming microbial mats so dense they look painted on. Over weeks and months, these chemical gardens become the foundation for entire ecosystems. Eel pouts drift between sulfide towers, shrimp swarm in writhing masses, tube worms find anchor in crevices still warm to the touch. And if another eruption comes, it can all be erased in minutes, a cycle of destruction and renewal so complete that the boundaries between ending and beginning feel irrelevant. There are no markers here, no signs declaring what has been claimed, what has been lost. The only evidence is change itself, a slow choreography of creation that has been unfolding for hundreds of thousands of years. Some scientists call low sea a preview of Hawaii's eventual future, a new island that will one day join the chain. But the timescales stretch beyond the comprehension of any single human life. We measure time in generations. Low sea measures it in millennia. On the decks of research vessels, this perspective has a way of quieting conversation. Even seasoned crews, people who have spent decades at sea, find themselves standing at the rail in the small hours, staring into black water that gives no clue to the mountain rising beneath it. Some say they feel something pressing back, a low tension in the air or a faint vibration underfoot. Others report a sense of scale so vast it feels like vertigo, an awareness that they are suspended over something as big as a continent, moving with a patience no mind can hold. In the laboratory, samples brought up from low sea are studied with rigorous detachment. Chemists quantify the sulfur content. Microbiologists culture new species. Geologists model the shape of the summit in three-dimensional grids. But even in the data, the volcano resists containment. Every time the measurements begin to feel familiar, low sea shifts again, introducing some new detail that resets the map: a fresh fracture, a new vent, a slope that has lifted imperceptibly, inching closer to the day when the first waves will break against basalt no longer hidden. There is an old Hawaiian saying that loosely translates to this: the mountain is patient. It is as true of low sea as any volcano above water. What is different here is how the ocean itself becomes an accomplice, smoothing eruptions into quiet drifts of sediment, cooling lava into unassuming mounds, disguising transformation as stillness. The Pacific has always been a master of concealment, and low sea is one of its greatest secrets. A reminder that even the seafloor is not final, only provisional. When you leave this place, when the ship's engines begin their slow churn toward the horizon, it feels as if something remains behind. A fragment of wonder you can't quite name. The knowledge that beneath the surface a mountain is rising, breath by breath, tremor by tremor, indifferent to our attempts to measure or understand. Someday it will breach the waves and claim its place among the islands. For now it waits, still growing, still dreaming, still becoming. And when the last buoy is hauled aboard, and the last sonar ping fades into silence, the sea closes over low sea as if it was never there at all. In the far reaches of the South Pacific, there is a place where the earth has chosen not to hide its wounds. A submerged caldera yawns beneath the Kermadec arc, a broken crown of rock and lava that seethes without respite. They call it Brothers Volcano, named for the early explorers who charted these remote waters. But the name does little to prepare you for the reality of what waits below. Here, in darkness deeper than any night sky, the sea boils against stone, and vents the size of houses bleed chemicals into a blackness that is anything but empty. When researchers first began mapping Brothers in detail, it felt like stumbling upon an undersea metropolis. Hydrothermal chimneys towered like spires, some rising 20 meters above the fractured crust, belching plumes so hot that the surrounding water shimmered in an invisible fury. Even the most advanced submersibles could only approach with caution, sensors shrieking as temperatures climbed toward 300 degrees Celsius. Yet, impossibly, life clustered here. Shaggy mats of microbes clung to the chimneys, pale shrimp crept through sulphurous jets, crabs picked over fresh mineral crust, as if this had always been their domain. In a way, it had. Brothers Volcano is old, older than any memory, older than our species. Every eruption is just another line in a story that predates every chart we've ever drawn. The caldera itself is a vast oval, almost 3 kilometers across, with walls that rise in terraces of volcanic debris. From above, it resembles the hollowed tooth of some colossal predator, its ragged edge biting into the ocean floor. But this is no ruin. The volcano is alive. The last major eruption in 1998 was so violent, it lifted the sea surface in a shockwave that raced across the Pacific. Even in quieter times, the chimneys are never truly still. They breathe columns of shimmering metal-laden fluids, forging new rock as quickly as the old breaks away. Divers can't survive here. Even remotely operated vehicles strain to last more than a few hours in the fierce chemical haze. The plumes that rise from Brothers carry arsenic, mercury, and acidic compounds potent enough to melt sampling equipment. But scientists return again and again. Wijuf calls and Tibin Knowles and Tibin, Self and of Coes and of Moise. The promise of discovery is too strong to resist. The volcano's fluids are rich in clues about Earth's past, how continents were born, how oceans were seeded with minerals, how life learned to survive in places no sunlight could reach. The first time a remotely operated vehicle drifted close to the caldera floor, it recorded something that even seasoned geologists called unsettling. From cracks in the basalt poured slow rhythmic pulses of gas, each exhalation bending the water around it like a mirage. Instruments captured vibrations too low for human hearing, resonances that made the submersible's hull hum as if something beneath the crust was knocking to be let out. For minutes at a time, the cameras went grainy with interference, then cleared again, leaving only the flickering glow of the chimneys and the steady fall of mineral flakes that drifted down like black snow. Some expeditions returned to find entire formations vanished. A tower that stood for a decade might simply be gone, collapsed into rubble by forces no eye witnessed. Other times, new structures have risen in their place, columns of sulfide and anhydrite so fresh, they still radiate heat. To work here is to accept that nothing is fixed. What a sick. The volcano does not care what we map or measure. It moves at its own pace, unbothered by our need for permanence. There is something humbling in that. Standing on a ship above Brothers Volcano, you feel the tension in the water, the sense that the surface is only a thin skin stretched over something vast and old and angry. At night, when the winds ease and the sky clears, you can see stars so bright they feel close enough to touch. But below, the caldera waits, breathing in the dark, forging new minerals and reshaping the seabed grain by grain. It is a reminder that our planet is still building itself, and that every certainty we cling to can dissolve in a single unseen eruption. The Maori have long believed these waters hold spirits that speak in tremors and plumes. When you watch the vents pour their columns of shimmering poison into the abyss, it's hard not to agree. Something down there is alive, not in the way we understand life, but in a way more patient, more relentless. Brothers Volcano will keep rising and falling long after every ship has rusted to nothing. It will outlast every name we've given it, every survey line we've drawn. And someday, when the caldera's rim finally lifts above the waves again, no one will be here to see it. The ocean will boil, the gases will burn the sky, and a new island will be born from a furnace no human hand can tame. Until then, we watch, we record, we pretend that our charts and samples can hold back the immensity of this place. But the truth is simpler. Here, beneath 3,000 meters of salt water, the Earth is still making itself. And every exhalation from Brothers Volcano is proof that the world you think you know is only ever temporary. The chimneys of Brothers Volcano are not merely geological curiosities. They are monuments to processes that began long before human memory and will continue long after it ends. When the submersibles glide low over the caldera floor, their lights catch glimpses of formations that look carved by an artisan's hand, fluted pillars banded in alternating crusts of gleaming metal and porous stone, archways formed where two vents have grown together in a slow embrace, and fragile spires, no thicker than a branch, yet rising 10 meters tall. Each one is a testament to the quiet, relentless work of chemistry and time. But these cathedrals of mineral are not fixed. Even over a single expedition, the landscape can transform. A towering chimney might erupt and crumble overnight, leaving only a mound of collapsed shards, steaming faintly in the gloom. When researchers returned after a 3-month absence, one of the main vent fields had shifted by nearly 20 meters. The sea floor had buckled like cloth. New fissures split the caldera floor, pouring jets of opaque fluid so dense that visibility dropped to nothing. Instruments lowered into those flows came back scalded and crusted with newly precipitated ore. Every descent becomes an act of humility, no matter how precise your charts. The volcano will remind you it will never be fully known. There is a kind of hush that settles over the control rooms when the live feed begins. You can almost sense the boundary you're crossing, that moment when the cameras pass from daylight into an environment shaped by heat and darkness. It isn't just the absence of sun that makes it feel alien. It's the knowledge that these processes are as old as the planet itself. The water is loaded with metals dissolved straight from the mantle. The gases that billow upward are the breath of magma chambers so deep that even our most sophisticated instruments can only infer their contours. And in that crucible, life not only survives, it thrives. Tube worms, their pale plumes waving in scalding water, anchor to chimneys that would dissolve a human hand in minutes. Swarms of tiny shrimp dart in and out of the jets, their shells laced with protective bacteria that feed on sulfur and iron. Even the rock itself feels alive, sheathed in mats of extremophiles that metabolize the invisible chemicals billowing from the cracks. The first time a sample core was brought to the surface, it emitted a smell so strong it cleared the deck, sharp and metallic, like scorched coins and rotten eggs. The scientists laughed then, exhilarated and exhausted. They knew it was the scent of creation and decay and everything in between. During one dive, the ROV pilot steered along a fault line where the sea floor rose in a long, jagged ridge. As the camera panned across the crest, something unexpected appeared, a long trail of freshly erupted glassy lava, still glistening like cooled tar. Even in the crushing cold of the abyss, the rock radiated residual heat. It had likely erupted only days before. No seismic alert had registered. No plume had broken the surface. It had simply happened in the vast quiet of the deep, a reminder that most of this planet's volcanic activity will never be witnessed, let alone understood. The mystery of Brothers Volcano does not end at its rim. The Caldera walls are riddled with hidden vents and fractures, each one an unpredictable conduit to the mantle. Submersible dives have recorded sudden blooms of milky fluid so thick the cameras see nothing but a featureless white screen. When the cloud clears, the topography has shifted again. It's like watching the sea floor breathe, inhale, exhale, reshape. And all the while, the sensors record tremors that flutter through the basalt like distant heartbeats. Even the silence here has texture. When the ROVs power down their thrusters to drift over a vent field, you can almost sense the tension in the water, the constant low thrum of heat rising through 1,000 tiny fractures. Sometimes, the hull of the sub vibrates in short, arrhythmic bursts, like a muffled knocking. More than one pilot has described the sensation of being observed, though by what no one can say. There is a temptation to see this volcano as an enemy, a place that poisons the sea, that devours equipment, and swallows any hope of permanence. But if you spend enough time studying it, the feeling becomes something more like respect. Brothers is not malicious, it is simply indifferent. It does not care who you are, or how much technology you bring to bear. It will erupt and collapse and rebuild at its own pace, and you are only ever a guest in its domain. And yet, for all its indifference, it has offered gifts. The metal-rich fluids that pour from the chimneys hold insights into the formation of ore deposits that once powered empires. The microbial mats contain enzymes that may someday fuel new medicines or biotechnologies. Even the unpredictable violence of the eruptions is a teacher, reminding us that Earth is never as static as we imagine it. When the ship pulls away at the end of an expedition, there is always a moment when the deck falls quiet. You feel the absence of that place, the sense of something vast and unknowable left behind. The volcano does not care. Its chimneys keep breathing, its caldera keeps shifting, and the sea above slowly closes over the disturbance until, from the surface, you'd never know anything remarkable lay below. But you remember, and long after the charts are filed and the samples labeled, you can still feel the heat of it, the nearness of something older and more patient than humanity will ever be. They say that in the darkness of Brothers Volcano, distance is measured, not in meters, but in thresholds. The first threshold is the cold. The instant the ROV drops through the thermocline, and the water around it sinks to near freezing temperatures. The second is the dark, when daylight vanishes so completely that even the memory of blue is gone. But the deepest threshold isn't one of light or heat. It's the moment the sensors begin to pick up the chemistry of the vents. The first trace of sulfur, the first whiff of hydrogen sulfide, drifting invisibly through the cabin's filtration. That's when everyone watching knows they've crossed into the true domain of the volcano. The submersible cameras capture scenes so alien that even seasoned pilots sometimes pause, hands lifted from the controls. Whole gardens of chimneys sprout from the caldera floor, each one exhaling white plumes in slow, billowing columns. Some look like stalagmites tipped with frost. Others have bloomed outward in cauliflower clusters, walls dripping with metal-rich precipitates. The most massive towers, called the cathedral and the organ pipes, loom tens of meters tall, their surfaces shimmering with superheated fluid that cools in an instant to form new rock. In these places, the water doesn't behave like water. It thickens with particulate until it moves more like fog. When the sub passes too near a vent, a veil of darkness swallows the feed, fine-grained metal sulfides condensing out of solution and falling like black snow. The first time it happened, the pilot thought the cameras had failed. It took minutes for the current to clear the cloud and reveal that everything was exactly where it had been, only newly dusted in a skin of mineral. The chimneys grow by millimeters each day. In weeks their contours can change so completely that a return visit feels like stumbling onto a different volcano altogether. New pinnacles rise, old ones split and collapse into talus slopes that sprawl across the basin floor. When a collapse happens during a dive, the vibrations rattle the submersible's hull, like a distant drumbeat. The debris cloud can take hours to settle, and in that interval, all you can do is watch and wait, cocooned in the dark, knowing the landscape is rewriting itself around you. Even the animals here seem carved from the same contradictions. The tube worms cluster by the hundreds in waving curtains of white plumes, their soft bodies thriving in water hot enough to cook flesh. Crabs scuttle across chimneys that could scald the skin from bone. Eel-pout fish drift between the pillars, their scales sheened with bacteria that feed on sulfur. No food chain here begins with sunlight. Every life in this hidden garden grows from the breath of the volcano. The chemistry is as brutal as it is beautiful. Fluids at some vents approach 300 degrees Celsius, yet the pressure prevents them from boiling. When a crack opens in the Caldera wall, it can vent clouds of CO2 so concentrated they turn the water into acid. One ROV pilot described the sensation of steering through these clouds as like piloting through dissolving air. On the monitor, the fluid folds and streams with mesmerizing grace, milk swirling in ink, but behind that beauty lurks annihilation. More than one probe has been lost when its housings corroded faster than the team could haul it up. Sometimes, the volcano reminds you how small you are. One survey mapped a fresh lava flow that had erupted between dives, a lobe of smooth black basalt wider than a city block. It wasn't there 3 weeks before. No warning, no quake at the surface. It simply happened. The venting gases thickened the water to the consistency of syrup, and the ROV had to climb slowly to keep from being swallowed by the rising heat. In the control room, nobody spoke until the drone was safely above the haze. Other times, the volcano is almost tender. A probe lowered into a newly opened vent found the water only slightly warm, an oasis where glass sponges had already begun to colonize the fresh rock. These fragile creatures, older than most lineages of life, had anchored themselves to stone no older than a few days. Even here, where the sea floor can rip apart without warning, life waits for the smallest foothold. On one dive, a pilot hovered near the cathedral, watching as fluid poured from fissures that glowed faintly in the lights. He turned the cameras outward, toward the open caldera. For a moment the vents receded into darkness, and it was possible to believe he was suspended in an endless void. Only the measured data, temperature, salinity, gas concentrations, reminded the team that there was structure in the blackness, that they were not simply adrift between worlds. Every mission here feels like a truce. You are allowed to witness, to record, but never to control. If the volcano decides to shift, all you can do is leave. Even the toughest submersibles have limits, and Brothers has ways of testing them all. Yet no matter the danger, no one ever forgets what it feels like to descend past that final threshold. The instant you cross into the caldera, the chatter on the radios always fades to a hush, as though everyone senses how old this place is, how indifferent to the brief flicker of our attention. When the ROVs finally ascend, their lights vanish into the dark like embers lifting from a pyre. The volcano is unchanged by our presence. It will continue to seethe and grow, to feed unseen ecosystems and create new minerals. It will breathe sulfur and iron into the sea for as long as this world has heat to give. And when the cameras go dark, the caldera closes in behind them, folding its secrets back into silence. You can almost feel it watching your departure, patient and unhurried, knowing you'll be back. There are moments inside Brothers Volcano when you almost forget that you're not watching the birth of a world. When the ROV's lights catch the shimmering curtains of vent fluid, and the chimneys glisten like wet bone, It feels less like a geological process, and more like something alive, breathing, secreting, reshaping itself in rhythms older than any human memory. The pilots call it the cathedral, not just because of its scale, but because of its hush. Even through a hull of steel, you sense the pressure in your chest, the way the sound falls away. The only noise is the low mechanical sigh of the pumps, and the tick of instruments logging data that will take months to decipher. In that darkness, perspective warps. You can forget the submersible is no bigger than a delivery van. The chimney walls soar out of sight, blackened by years of mineral rain, edges rimmed in the pale, outlines of microbial mats clinging to their only home. Some of those microbes are older than the caldera itself. They survive here by harvesting the energy of hydrogen sulfide, a compound that would poison almost every surface creature on Earth. Inside their delicate cells, enzymes churn sulfur into fuel, weaving life out of what we would call a wasteland. But no scientist who has hovered here would ever call this place dead. The vents are seething with small determined lives, crabs, shrimp, archaea, worms, and each species locked into the labyrinthine puzzle of hydrothermal chemistry. When the vents roar, they do so without warning. More than once, the ROV teams have watched in awe as a fissure split in real time, a gout of boiling water and black particulate erupting into the caldera like smoke from a hidden forge. The plume can rise 20 meters before gravity rains it back down in a silent drifting curtain. Once a pilot tried to follow the particles with the camera. He described it later as watching a snowfall that melted before it landed, each flake carrying minerals freshly birthed from deep in the Earth's crust. On the caldera floor, the lava domes crack and heave. New fissures appear every season, some no wider than a finger, others broad enough to swallow a diver whole. The ROV can only trace the outlines of these scars. What lies beneath them is unknowable, a realm of magma chambers and molten rock whose temperatures exceed 1,000 degrees. If the crust beneath Brothers ever fails in earnest, the resulting eruption would dwarf any surface volcano in living memory. It has happened before. The scars are visible in sonar, massive caldera walls slumped inward, thick flows of solidified lava frozen mid-collapse. But you don't have to see an eruption to understand the volcano's power. You only have to drift a few meters above the largest vent fields. There the currents change character. Instead of the slow, cold creep of abyssal water, the columns rising from the vents carry invisible momentum. The submersible's instruments show swirling eddies thick with superheated minerals, iron, manganese, sulfur. If you extend a probe, it returns crusted in fresh deposits within hours. And everywhere, life clings to these chimneys, strange crabs with blind, glassy eyes, worms with crimson plumes that sway in chemical tide. One of the most haunting discoveries came during a maintenance dive on an instrument array bolted to the caldera rim. As the ROV maneuvered in the dark, its cameras swept across a tall chimney the pilots had named the Choir. Near the base, a small cave-like opening yawned, and inside, something moved. Not a fish, not a crab. A column of pale, filamentous organisms undulating in slow synchrony, their bodies longer than eels, coiled together into a single trembling mass. When the lights touched them, they retreated in a ripple that closed the hollow like a curtain. The pilot later said it was the closest thing to sentience he'd ever felt from a place. The Choir eventually collapsed under its own weight. By the time the team returned months later, nothing remained but rubble cooling in the darkness. That is the other truth of Brothers. It is always erasing itself. The vents are built only to fail, each chimney destined to topple as the volcano grows new fissures beneath it. This constant cycle of creation and destruction has been going on for tens of thousands of years, and will likely continue for millennia more. Somewhere near the caldera's heart, the water is superheated enough to dissolve rock itself. In these pockets, mineral-laden fluids rise so fast they can burn away the sensors in seconds. Instruments melt or corrode in place, leaving behind twisted husks as mute evidence that something deeper and hotter was waiting. For every reading that makes it back to the lab, countless others vanish into the abyss, unrecoverable. And yet, each expedition returns richer in understanding. The volcano teaches by slow degrees how life can flourish without sunlight, how geology and biology are not separate realms, but one great engine. The lessons come at a price: lost equipment, ruined probes, risk to the pilots, but everyone who's watched the vents erupt agrees it's worth it. Because no simulation, no computer model, no graph on a screen can capture the shiver of seeing the Earth's deep heat emerge into open water. The final moments of every dive feel like a reluctant farewell. As the ROV begins its slow ascent, the lights of the cathedral recede, and the shimmering currents fall away into black. The cameras tilt back one last time to glimpse the labyrinth of chimneys, the billows of invisible steam, the colonies of creatures clinging to sulphurous stone. Then the lights fade out completely, and Brothers Volcano folds its secrets back into the dark, waiting for the next chance to speak in heat and mineral, a place indifferent to our curiosity, yet richer for having been seen. A reminder that the most alien worlds do not orbit distant stars, they bloom in silence beneath our own oceans. The Bransfield Strait does not welcome visitors. Even in the fleeting Antarctic summer, when the sea ice splinters into loose drifts, and the sun hangs on the horizon in a perpetual twilight, this place remains an expanse of cold and quiet menace. Ships that venture here do so with caution, their hulls thick against drifting bergs, their instruments tuned to catch any whisper of what stirs below. On the chart, Bransfield Caldera appears as little more than a depression, a basin more than a crater, a place defined by the absence of mass rather than the eruption that carved it. But those who have studied its floor understand that emptiness is only the surface story, for beneath these waters, the Earth still remembers how to rupture. The first modern glimpse came from seismic arrays installed to monitor microquakes along the Antarctic peninsula. At first the signals were faint, a series of harmonic tremors, too regular to be mere tectonic flecks. The frequency suggested magma shifting below the crust, rising, pausing, cooling just enough to fracture the rock above it. Then in 2012, the caldera spoke more clearly, a pulse of seismic energy that rolled outward like a bell toll, followed by a bloom of heat that rose through 1,000 meters of frigid sea. No one saw the eruption itself, no ship was near enough to witness it, but satellite sensors detected the temperature surge, and drifting floats recorded the sudden chemistry shift, an exhalation of volcanic gases mixed into the water column, enough to drive the pH lower for miles around. The first expedition to confirm the event arrived months later, when winter had retreated. They found a seafloor scoured raw, blanketed in ash as fine as flour. The ROV pilot described it as landing on a desert of black snow. Nothing moved, no fish, no worms, only the slow collapse of still warm sediment into fresh fissures. The hydrophones recorded an eerie intermittent hum, rising from vents hidden in the soft drifts. It was the sound of gas bubbling through crust, a reminder that the caldera hadn't returned to sleep. What makes Bransfield different from many other submarine volcanoes is the contradiction of its setting, a landscape of eternal ice underlain by molten unrest. From above you can look across a horizon as featureless as a salt flat, white and silent, but a few kilometers down, the crust is thin and restless, rifting under pressures no glacier can hold back. As the ROV crawled across this hidden battlefield, its cameras revealed features no one expected. New cones, small steep hills of basalt that hadn't existed before the eruption, pale chimneys venting faint heat, and among them, curious marks etched into the ash. The pilots thought at first they were debris trails, perhaps cables or dragged equipment, but the patterns curved too smoothly, coiled in deliberate arcs, as though something had swept the seafloor in search of purchase. The marks ended abruptly, at the rim of a new fissure. To this day, no one agrees what made them. The further the expedition pushed into the caldera, the stranger the readings became. Temperatures fluctuated by tens of degrees within meters, creating invisible walls of warmth in the near-freezing dark. The ROV's depth sensors began to wander, as if the pressure itself was uneven. More than once, the vehicle's lights dimmed for no reason, then returned. Every anomaly carried the same lesson: here the rules are provisional. But not everything in Bransfield is violent or deadly. The same chemical eruptions that scour life away also create the conditions for it to return. Within months, New bacteria had colonized the fresh rock, forming thin biofilms along the cooled lava. By the following year, small crustaceans and polychaete worms were seen drifting back. A field that had looked dead now shimmered with potential colonies that would climb the food chain over years and decades, nourished by minerals and heat the surface could never provide. Standing on the deck of a research ship above this hidden drama, it's easy to feel small, easy to imagine that somewhere far below, the crust is already preparing its next exhalation. For Bransfield has erupted before and will erupt again. Some of its cones are less than a century old. One day, the seafloor will split without warning, and heat enough to vaporize steel will pour into the abyss. When that day comes, no one will see it in real time. The ocean will keep its secret. The ice will drift overhead in silent witness, and only days later, when the chemical plumes rise and the seismic echoes shiver through the water, will the world know that another pulse of creation and destruction has come and gone. And those marks in the ash, the curving trails that ended at the fissure, they will be buried beneath fresh layers of glassy debris, erased like all stories here eventually are. Because in the Antarctic deep, nothing holds still for long, not the crust, not the currents, not even the memory of what passed before. The second expedition to Bransfield Caldera arrived in late summer, when the sea had calmed just enough to allow deployment of heavier equipment. It was not curiosity alone that brought them back, but necessity. The caldera's eruptions had disturbed circulation patterns across a wide swath of the Southern Ocean. Instruments hundreds of miles away were recording anomalies, temperature gradients that didn't match known models, drifting clouds of fine sediment that occluded sonar for weeks, a subtle acidification that hinted at deeper changes. The ship's crew prepared with the caution of those who knew what the seabed could do. Every probe was redundantly tethered, every ROV programmed with return fail-safes. The mission plan was simple: retrieve chemical samples, remap the crater floor, and record any signs that the vents were reawakening. Yet, when the first dives began, it was clear that something deeper than heat or gas was at work. The caldera had changed. The same slopes that in the first expedition had been soft and layered in ash, were now hardened into brittle crust. Long fractures laced across the seafloor, like veins of black glass. When the ROV approached the largest fissure, the cameras revealed something uncanny. The crack pulsed, not visually, but through pressure, a slow expansion and contraction, as though the earth itself were breathing in darkness. Each time the fissure widened, a faint shimmer of bubbles escaped, carrying gases that would later be catalogued as rich in carbon dioxide and traces of methane. Above that restless fracture, the water shimmered in the ROV's lights. It looked like heat distortion, but moved with a different rhythm, curling and slipping across the camera's field in bands, almost like filaments of smoke. Some on the surface thought it was particulate stirred by the thrusters. Others insisted it moved too deliberately, folding inward and vanishing as if in response to observation. They catalogued these illusions, noting that the sensors never failed, the pressure never spiked, but that the recordings always felt incomplete, like something was erasing part of the story as it happened. The expedition also brought a new suite of autonomous floats, small cylinders designed to drift in the currents above the vents and collect time-lapse data. Each was equipped with chemical samplers and acoustic loggers. Some floated for days, transmitting steady signals. Others vanished within hours, their last data packets corrupted with static that resolved into nothing more than prolonged irregular pulses, like the caldera was whispering in a language the instruments couldn't translate. One float, recovered weeks later by a separate vessel, bore evidence of heat damage. Its titanium casing was warped along one side, blistered in a pattern that no known hydrothermal vent could produce. The scorched metal, when analyzed, showed traces of elemental sulfur fused into the outer layer. Whatever had touched it had been hotter than boiling water, hotter than the crustal outflows usually measured here, something closer to the raw temperatures of fresh magma, despite no eruption being recorded at that time. The researchers logged every anomaly, every trace of heat, every chemical signature. The reports filled volumes of data, but what haunted them most was what could not be quantified, the way every dive felt watched. The ROV pilots, hardened by years of abyssal mapping, spoke in low voices of how the cameras would sometimes catch glimpses of motion at the edge of light, ribbons of turbulence that seemed to recoil from illumination. More than once, an operator would swear that the seafloor itself shifted subtly, the angles of the new lava ridges, softening when studied too long, like the landscape was unwilling to be defined. During the final dive, as the ROV traced the margin of the caldera, its light swept across a shallow depression. The shape was smooth and circular, no more than 20 meters across. At its center lay a single vent, low and unobtrusive, surrounded by what looked like filigree, a lacework of mineral deposits built up layer by layer, in fragile arches. The effect was delicate, almost beautiful, but when the chemical sensors drew near, the water composition changed so quickly that alarms triggered on the surface. Sulfide levels spiked, pH plummeted. In less than a minute, the readings suggested conditions lethal to most known life. The vehicle reversed, drifting back into safer gradients, but the memory lingered. This place was not dormant, not quiet, not settled. It was simply biding time between outbursts. By the end of the mission, the team had confirmed that Bransfield caldera was still active, perhaps even entering a new eruptive phase, but no one dared predict exactly when the next event would come. Down here, the only constant was transformation. As the last equipment was lifted from the sea, a hush fell across the deck. It wasn't fear, not quite, more a recognition of scale, that under this glacial sea, the planet was rewriting itself, inch by inch, eruption by eruption, while no witness but cold water and the occasional curious eye could record its story. And in the hours after departure, as the ship steamed north, the hydrophones left behind continued to listen. Long after the hull was gone, the caldera kept breathing in the dark. When the team returned to port, exhausted and subdued, the logs were handed off to a consortium of geologists and marine chemists who specialized in hydrothermal systems. But even among experts, accustomed to the bizarre, the Bransfield data held inconsistencies that no model could easily reconcile. The chemical analyses suggested fluxes of dissolved metals, iron, manganese, and traces of rare earth elements, in concentrations that would normally only appear during major crustal upheavals. Yet no quake had been measured, no plume had breached the sea's surface. The caldera was rewriting its chemistry without the violence that should have accompanied such change. Some of the scientists believed this was a slow leak from a deeper magmatic body, an intrusion creeping upward beneath layers of solid crust, unstoppable but too gradual to trigger classic eruption signals. Others proposed more radical explanations that the caldera was part of a linked system spanning the Antarctic peninsula, a chain reaction of volcanic behavior waking from centuries of relative sleep. But those were hypotheses meant for papers, for conference halls and grant proposals. The crew who had looked directly into the pulsing fractures carried different convictions, less scientific, more visceral. They described the caldera's atmosphere not merely as hot, not merely toxic, but aware. Each time they launched an ROV, or lowered a probe, it felt as if something in the depths weighed their curiosity against its own patience. Something ancient, neither welcoming nor hostile, only watching. Months passed and the sea iced over again, sealing the caldera under fresh winter armor. Satellite altimetry tracked subtle bulges along the seafloor, gradual uplift measured in centimeters. No more, but steady, like a lung inflating in cold darkness. During one rare clear interval, a new set of hydrophones was airdropped onto the ice and allowed to melt through, sinking slowly until they anchored on the sediment below. Within hours of activation, they detected the same rhythmic pulses noted in the first expedition's logs, spaced at intervals too regular to be random, too variable to be the work of simple degassing. These were not the explosive bursts of Surtsey's birth, nor the violent shocks of Tonga's eruption. This was something quieter, more patient, a process unfolding over months or years, and in the spaces between the pulses there was always that faint background tremor, like something vast shifting just below perception. In the control rooms thousands of kilometers away, audio engineers and oceanographers took shifts listening through filtered feeds. They heard the slow churn of convection currents, the occasional crackle of ice calving into the sea, the low drone of tectonic murmurs. But sometimes, Layered beneath it all came a resonance no one could place, a bass note so deep it bordered on feeling rather than hearing. Some called it the heartbeat of the volcano, others weren't so sure it belonged to the earth at all. By early spring, the caldera's shape had shifted again. Autonomous gliders, programmed to pass overhead, returned with bathymetric readings that showed a new mound forming inside the central basin. The feature was small, no more than 15 meters high, but it hadn't been there the previous season. Its slopes were steep, crusted in fresh glassy rock, warm to the touch when the next ROV approached. No vents punctured its summit, no fumaroles marred its skin, just a perfect dome of cooling lava, risen silently under miles of pressure. The pilots watching the live feed held their breath as the ROV drifted closer. For a moment, the lights caught a shimmer, an iridescence across the dome's surface like oil on water. The reflection was gone in an instant, dismissed as an artifact of angle and refraction. But later, reviewing the archived footage frame by frame, a technician paused and called in her supervisor. There, in a single frozen image, the reflection resolved into something stranger, not color, but pattern, a radiating spiral, too precise to be an accident, etched in subtle ridges across the dome's face. They argued over the image for hours. Some saw a trick of light, others insisted it was real. A geologist, tired and exasperated, suggested they leave interpretation to philosophers, but no one could deny what the sensor logs confirmed: the dome's temperature was rising again. Plans were drafted for another survey, another season, another attempt to record what the volcano was becoming. But some on the team began to question whether observation was harmless, whether the act of watching, of sending light and noise into that hidden world, might be the catalyst for what came next. In their quarters, more than one pilot found themselves dreaming of the caldera, not as it appeared on screens, but as a vast hollow mind, pulsing under ice, aware of every intrusion. In those dreams, it never erupted in rage. It only waited, its slow warmth gathering like breath, and the feeling waking up was never quite fear. It was recognition. Recognition of something alive, old beyond reckoning, and no longer content to remain silent. Above the ice, the southern ocean lay calm as ever, wind scouring the waves, darkness reclaiming the horizon. But in the darkness below, the volcano continued to rise, unhurried, unbothered, unafraid, waiting. As autumn waned into the long Antarctic night, the research vessel was replaced by a more permanent platform, an unmanned station, tethered by cables thick as a man's wrist, bristling with instruments and acoustic beacons. From the surface it looked almost insignificant, a speck of steel and antenna lost amid the freezing mist. But beneath, its sensors reached into the caldera's darkness, like the tendrils of a patient machine, gathering proof that the seafloor was not only restless, but evolving. The first readings seemed ordinary, almost disappointingly so. Minor tremors, harmless venting, shifts in the chemistry of dissolved gases. But then the patterns began, cycles of pressure change that repeated every 74 minutes. Exactly. The intervals were so precise that some suspected a calibration fault, but cross-checks against satellite altimetry proved them real. A rising and falling of the seafloor, like the chest of something alive. Each pulse displaced millions of cubic meters of water. The movement should have raised swells, disturbed ice, left visible clues on the ocean's surface, but none appeared. The sea remained a placid pane of darkness, and the station above lay still, its lights blinking in slow rhythm, a silent echo of the volcano's heartbeat far below. As the data accumulated, researchers began to notice other anomalies. Samples retrieved from the caldera's rim contained microcrystals of silica, but unlike any seen before, under the microscope, their forms were almost architectural, hexagonal spires. So regular, they looked sculpted rather than grown. No known process accounted for them, but one volcanologist quietly called them a language. No one laughed. The longer the station recorded, the more it hinted that the Bransfield caldera's awakening was not just an eruption waiting to happen, but the slow revelation of something more profound, a transformation in the nature of the seabed itself. It was as though the volcano was building, layer by layer, an edifice no one could yet see. Late in June, the platform's seismometers registered a sequence that defied every model, a harmonic tremor, lasting 4 hours without pause, its frequency oscillating in intervals no tectonic movement should produce. The waveform, when graphed, showed a complex spiral that repeated with perfect fidelity. One geophysicist spent 3 days trying to translate the pattern into equations before admitting he felt he was decoding a message rather than a signal. During the event, the water temperature at the caldera's center rose by 2 degrees Celsius, enough to drive venting, enough to suggest that magma was rising, but no eruption followed. Instead, the heat receded as if deliberately withheld, and when divers returned, they discovered something that turned theory to disbelief. A new vent had appeared, a narrow fissure lined in fresh basalt glass, its rim etched in the same repeating hexagonal symbols found in the silica samples. The images caused a brief sensation in scientific circles. Papers were drafted. Funding was proposed for further missions, but quietly, those who had spent the most time in that cold theater of shifting rock and invisible heat found themselves speaking less often. They shared a sense that the caldera had not revealed itself out of accident or curiosity, that it had always been there, patient and aware, and that it had decided to let itself be known on its own schedule. On the final survey dive before the darkness of polar winter closed in, the last ROV descended through the wreath of rising mineral haze. Its lights cut a narrow path along the fractured rim, drifting over fields of spires that glistened like knives in the darkness. In one corner of the video feed, a shape moved, a wavering bulge in the haze, impossible to measure, impossible to capture in still images. It did not resolve. It did not react. But for the 30 seconds it passed across the camera's range, the audio feed grew silent. No hum of motors, no ping of sonar, only a stillness so complete it pressed on the ears like pressure itself. When the ROV surfaced, the instruments returned to normal. The recordings remained intact, except that the frame containing the passing shape was corrupted, overwritten by static that no technician could clean. In the weeks after the station was mothballed, and the last researchers returned home, there were dreams. Not nightmares, exactly, but vivid recollections of a place more enormous than any vessel or camera could capture, a cathedral of stone and darkness, breathing in the depths, unhurried by time. Many of the crew awoke from these dreams certain that it was not the volcano they had seen, but the memory of something older than land, something that did not erupt, something that simply waited, refining itself in slow, patient heat. In the final report filed to the Research Council, the project leader wrote in his conclusion, "Bransfield is not asleep, nor is it waking. It is simply there, immense and whole, and we are the momentary disturbance passing across its thought." No one amended the sentence, and in the months that followed, the sea froze over again. The ice thickened, unbroken by vents or plume, but below that skin of quiet winter, the caldera still shifted, still warmed, still gathered its slow geometry in silence, waiting. The Aegean Sea conceals places that look ordinary until you learn their history. Kolumbo crater, hidden a few kilometers northeast of Santorini, is such a place. From the surface, the water seems harmless, just a patch of deeper blue beyond the last tourist boats. But in 1650, this was the source of an explosion so violent that boiling pumice rained onto ships miles away, and the air filled with clouds that turned daylight into dusk. The eruption created a new island that vanished within months as the caldera collapsed into itself, leaving a basin no one dared approach for generations. Centuries passed, and the crater gradually slipped out of common memory, but scientists never forgot. In the early 2000s, marine geologists returned to map the vent fields and discovered that Kolumbo was anything but extinct. Sensors registered a constant outflow of carbon dioxide and sulfur-rich plumes rising through fractures in the seafloor. Divers sampling the vent water described the sensation as wading through an invisible tide, warm and corrosive, capable of stripping protective coatings from their instruments. They described it as a place that seemed somehow aware of intrusion, as if the pressure itself responded to the smallest disruption. A research expedition in 2016 approached with caution. Their mission: install a set of monitoring pods along the caldera rim to detect even the slightest sign that magma was nearing the surface again. As their submersible descended, the sea turned opaque with drifting silt. The pilot relied on sonar to track their position. Each pulse of the scanner revealed an uneven landscape, a floor crusted with sulfur towers and streaked with gullies of pale sediment. Every few minutes, faint vibrations shivered through the hull, impossible to predict, like an echo returning from some deep chamber under the rock. The closer they moved to the center, the stranger the readings became. Temperature readings swung in steady cycles, climbing, falling, then climbing again. The water pressure climbed in waves that had no correlation to any known tide. From time to time, the silt cleared, revealing an intricate network of ridges, like ribs frozen in yellow mineral, arching away from the main vent. One diver watching from the control station felt an uneasy sense that the formation wasn't random at all. It looked too precise to be the result of chance. When the first sensor was deployed, the water around it calmed. The second landed on a ledge crusted with sulfur, so brittle it cracked as the anchor set in place. The impact released a plume of gas that drifted upward, carrying fine bubbles of acid. Even behind reinforced viewports, the divers watched the column rise, each particle catching their lights and scattering it into shifting patterns. One described it later as the closest thing to seeing the ocean itself exhale. They logged readings from the probes, carbon dioxide levels 10 times higher than any baseline in the region, temperatures spiking by as much as 20 degrees Celsius in narrow bands. Each vent seemed to operate on its own rhythm, sometimes silent, sometimes sending sudden bursts of gas that distorted the water around them. On the ship above, the crew traced every fluctuation on live graphs that scrolled with red spikes. The lead scientist had spent decades studying hydrothermal systems, but even he couldn't fully explain the coordination in those pulses. It was as though the vents were communicating across invisible channels. At the center of the crater, the final sensor waited in its cage, dangling from the deployment rig. As the submersible eased forward to lower it, the pilot noticed something odd. The sediment on the floor shifted, then settled again in a shallow circular depression. The movement was subtle, almost easy to ignore, but instruments confirmed it. The surface had drawn inward, a slow collapse too uniform to be a landslide. One by one, the divers focused their cameras. A faint current spiraled outward from the depression, stirring filaments of sulfur that curled in thin arcs. They watched in absolute silence as the depression widened by several centimeters, then stopped. No new gas release, no surge in heat, just that hollow indentation, a reminder of how close the forces under the crust remained to the open sea. When the last sensor was anchored, a single vibration rolled up through the submersible. The hull creaked as if under sudden strain, then everything fell still. One diver later admitted he was convinced, in that moment, that something in the rock had noticed them, had measured every probe and camera, and decided to let them go. The ascent was steady. In the dark water above the crater, the sediment gradually thinned, revealing the Aegean's calm surface waiting to erase every trace of the disturbance below. When the team returned to port, they carried hours of video and streams of raw numbers, but none of it felt more real than the memory of that shifting hollow in the crater floor. In the weeks that followed, analysis of the data revealed something no one expected. The fluctuations in gas output and temperature formed a repeating wave, almost identical to the historical accounts that preceded Kolumbo's last eruption. It wasn't proof that another explosion was imminent, but it was a clear sign that the processes that birthed the crater were still evolving. People in Santorini went about their days unaware that the sea so close to their shores held a chamber still changing, still releasing gas, still shaping the water column in ways no satellite could see. And on research vessels miles offshore, scientists continued to watch their screens, studying graphs that hinted at the possibility that the past was not finished speaking. By the time dawn broke over Santorini, the research vessel was already plotting the next series of passes across the crater. Sleep came fitfully to the team. Every few hours, someone would slip back to the monitors to recheck the graphs. as if the shape of a curve might warn them before the sea itself did. The recordings from the descent still played in loops, each replay bringing a new detail into focus. The way the sulfur filaments had curled in precise arcs before dissolving. The moment when the sediment drew inward like a single exhalation. Even the divers who had seen volcanic vents around the world agreed there was something different here, something in the way the pressure rose and fell, as if guided by intention. Kolumbo wasn't the largest submarine volcano. It wasn't even the most studied, but there was an immediacy to it that unnerved them, as though the distance between observation and consequence had narrowed to a single heartbeat. Every reading confirmed the system remained active, not just in heat or gas, but in movement. And it was movement that worried the team most. The chief geochemist spent hours cataloguing the vent emissions. Each vial of sampled water came back with acid levels that blurred the line between ocean chemistry and corrosive solvent. In places, the vent plumes had etched small channels in the Caldera's crust, pathways that widened over time. It was as if the seafloor was gradually hollowing itself out from within. At the center, where the depression had formed, no probe dared linger too long. Instruments picked up small regular vibrations, tiny shifts that repeated every 23 minutes, their cause unknown. No one said it out loud, but the pattern sounded too much like a pulse. When the submersible prepared for a second descent, a hush settled over the deck. Even the most seasoned crew members avoided meeting each other's eyes. The first dive had shown them a place unwilling to stay dormant. Now they were returning, knowing it might not be patient twice. The launch was silent. From the surface the water revealed nothing, a blank canvas of mild ripples and reflected sky. But as the submersible dropped below the thermocline, visibility dissolved again. Particles drifted past the portholes in slow cascades. The pilot kept one hand on the manual ascent controls, his breath loud in the headset. Every 10 meters, the instruments beeped out another set of readings. Pressure steady, temperature rising, dissolved gases climbing toward levels that should have warned them back to the surface. They didn't turn back. At 500 meters, the crater rim reappeared. This time the slope seemed changed, as though the seafloor had shifted in the hours since their last visit. One ridge had collapsed inward, a slope of yellow sediment spilling down toward the central basin. Heat bloomed in irregular bursts, caught in infrared as rippling patterns that reminded one observer of old film burning in slow motion. It was beautiful in a way no one admitted. The plan was to set a string of pressure sensors across the rim. If any sudden uplift occurred, any movement hinting at rising magma, they'd have a record. But as they moved to deploy the first unit, a vibration passed through the hull so clearly that everyone on the ship above felt it, a low resonance like the chime of an enormous bell underwater. The sound didn't repeat. One diver in the sub described the moment as the feeling of stepping onto a floor that shouldn't be trusted, like standing on thin ice with warmth rising beneath. He spoke into the recorder, voice so calm it surprised even him. "We're in the right place," he said. No one replied. The second sensor was set in a shallow trench where the vent gases streamed out in ribbons. The currents tugged at the housing, swirling sulfur particles around it in slow spirals. It was hard not to imagine that the seafloor was breathing, each plume an exhale, each stillness a pause to consider. Outside the porthole, the sediment shifted again. This time, no one could pretend it was imagination. The depression at the crater center expanded by almost a meter, the edge crumbling in silence. Gas billowed in sudden clouds, reducing visibility to arm's length. One by one the sub's cameras switched to sonar. On the monitors a new hollow took shape beneath them, wider and deeper than before. The pilot tapped the ascent control, prepared to leave. But the chief scientist leaned closer to the screen, voice low. "A few more minutes," she said, and they stayed. When the gas cleared, the depression remained a wound in the seafloor, perfectly round, its edges impossibly smooth. Every reading spiked, GOPO, at saturation. Pressure higher than any previous pass. The temperature climbed in fits, a heat that seemed alive, pulsing in waves that no tide chart could explain. For one moment, the pilot swore the walls of the hollow contracted inward, just slightly, like something flexing far below the crust. No one spoke again. The sub ascended, each meter carrying them back toward the ordinary blue of the upper ocean. As the Caldera floor faded from view, the pilot felt something almost like relief, until the final sonar scan returned one last shape at the center of the crater, a darkness so dense it defied reflection, a gap without echo. Back on deck they offloaded the sensors in tense quiet. Each bore the record of those last vibrations, rising, falling and rising again. The logs joined the rest of the data, which no one fully understood, not yet. Kolumbo had reminded them, it was not an artifact of history, it was a presence, a place where the sea and the earth conspired to keep their secrets just beyond reach, and no matter how carefully they measured, or how long they watched, some part of that caldera would never be mapped. It didn't need to be, it was awake. When the logs were reviewed back on shore, the recordings offered no comfort. The data from the submersible was too clean in some places, too fractured in others. There were entire minutes when every sensor recorded nothing at all, not even baseline noise. As if in those intervals, the water itself ceased to exist. The archive labeled these gaps as instrument anomalies, but in every debrief, no one called them that. They were called pauses, like something had decided what could be measured and what must remain hidden. The next expedition was delayed for weeks. Bad weather was the official reason, but everyone knew it was hesitation. Even the most rational voices in the team struggled to explain the sense that Kolumbo had responded to them. It wasn't the measured danger of an eruption that could be charted. It was something stranger, a deliberate unpredictability, a sense that the volcano wasn't content to remain a feature on a map. On the morning they finally sailed again, the sea lay flat as glass. The caldera's coordinates marked a dark patch beneath the dawn light, a place where the water pooled differently, as though the basin's shape reached up to the surface. One of the geologists, half in jest, called it a mirror, but no one laughed. They approached the site carefully, sonar sweeping for any new collapses. The crater had grown again, not by much, maybe half a meter deeper in some sections, but enough that every contour line in their charts had to be redrawn. It was becoming a habit, as if Kolumbo insisted on erasing their work in slow increments. Each survey pass felt more like an act of intrusion. Each sample retrieved seemed like a fragment taken without permission. The divers prepared to descend, checking their equipment with the same mechanical precision they'd rehearsed 100 times. But no routine could dull the unease. Everyone felt it in the hush that settled over the deck, in the way even the radio operator whispered as she relayed coordinates. Below, the currents shifted in lazy spirals. The lights of the submersible traced their way down the crater walls, painting pale arcs across the sulfur-crusted rock. A heat shimmer drifted up in veils. The water grew hazy with dissolved gases. Visibility dropped to less than 2 meters. It was like sinking through memory instead of seawater. They set the first seismometer at the rim. The process took longer than planned. Every few minutes, the instruments would glitch, streaming strings of meaningless characters across their displays. Only when the sub repositioned did the readings clear again. It was as if the equipment itself grew unsteady when it neared the central hollow. At the crater's edge, the second unit was lowered into place, and there it happened again, that same resonance that had filled the hull before. A vibration so deep, it wasn't quite sound, but a sensation that passed into bone and lingered like an echo. This time, it didn't fade right away. For almost a full minute, the low tone held steady, rising and falling in a slow rhythm. When the pilot tried to describe it later, he said it felt like standing near the heart of something alive, something breathing. The sonar scanned again. No new cavities, no sudden motion. But in the shadows beyond the beam, the darkness felt thicker. Not in any way the instruments could prove, just a shared certainty that something immense waited just out of reach, content to let them know it was aware. On the deck above, the readings appeared as a simple waveform, peaks and valleys, clean lines with no interpretation. But the technician who watched the graph said she almost recognized the shape, like a pattern she'd seen before. When asked, she couldn't explain what she meant. Only that the rising and falling looked familiar in a way she refused to articulate. Inside the sub, the final sensor was placed. At that depth, the gas content was nearly lethal. Every valve hissed with a pressure that could rupture the suits in minutes. The pilot called time, and the ascent began. No one spoke as the hull rose through the haze. The lights gradually brightened from the deep orange of sulfur back to the clear blue of shallow water, and all the while, the comm line remained silent. Not a glitch, not static, just a stillness that stretched the minutes into something uneasy. When they breached the surface, the team waited for relief to set in. It never did. Even as fresh air filled the suits, the sense of being watched didn't lift. The deckhands hauled the instruments aboard. Each unit came back intact, but their logs told the same story. Clean data, interrupted by intervals of impossible absence. Pressure readings that fell to zero without any corresponding drop in depth. Temperature plunges that reversed in seconds. None of it made sense. One diver remained seated for nearly an hour, helmet still in place, staring at the sea. He didn't move until someone gently touched his shoulder. When he finally stood, he didn't look back at the water. Later he would only say that he'd felt the crater's attention, as though all that heat and pressure was focused, for just a moment, on him alone. Back on land, the analysis began again. Charts redrawn, readings checked, files copied into archives where future expeditions could pretend to find clarity. But every person on that vessel knew the truth, even if they couldn't prove it. Kolumbo wasn't just a volcano waiting to erupt. It was a place that chose when to be seen. A place that measured them in return. And whatever it was that breathed beneath the crust, it hadn't finished rising. For days after the dive, the crew avoided speaking of the final vibration. It lingered in memory, like the residue of a dream, one you never fully wake from. The technicians insisted it was harmonic resonance, that the seafloor structure amplified some deep tectonic motion, but the divers didn't believe it. There was something about the way the tone had fluctuated, almost like a response, too precise, too measured. When the logs were transcribed, the lead geophysicist noticed a pattern buried in the lowest frequencies, a timing that repeated every 94 seconds. No natural process matched it, no vent release or shifting plate aligned so perfectly. In the margins of her report, she penciled one sentence before crossing it out. Later, she confessed what it said. It was listening. The next expedition was cancelled. No funding agency wanted to risk further incident after the equipment failures. But unofficially, the reason was simpler. No one volunteered. Even the most experienced hands spoke in circles when asked if they'd return. They never used the word fear. They called it caution, prudence, respect. But you could hear it in their voices, the way they trailed off mid-sentence, remembering the soft rise and fall of the sea around the crater, like something exhaling just below the threshold of sound. Months later, satellite bathymetry was used to check for changes. And there it was again. Kolumbo had grown. A new fissure extended from the northwest wall, a narrow seam that split the crater floor by several meters. But more unsettling was what surrounded it. The sediment had shifted in wide arcs, as though something enormous had moved beneath the silt, stirring it in slow, deliberate spirals. Even from orbit, you could see the trails. They traced paths toward the edges of the basin, faded into darkness, where the satellite's radar could no longer penetrate. No current could have left such marks without dispersing them. No vent could have raked the sediment so evenly. It looked, one analyst admitted, like tracks. In the fishing villages along Santorini's southern shore, old stories resurfaced, fragments of local superstition never written down. Some elders spoke of days long before the last catastrophic eruption, when boats went missing on windless mornings. When the sea lay flat and blue, luring sailors too close to where the water grew warm and still. They said the crater had always been there, long before people named it, a wound in the seafloor that never fully closed. One diver returned alone, months after the team had disbanded. He rented a small craft and sailed before dawn, dropping anchor at the precise coordinates where the last vibration had been felt. He brought no instruments, Only a weighted line and an old hydrophone, the kind used before digital systems became standard. He recorded for 6 hours. No ship's log was kept. No transcript survives. He came back at dusk. His colleagues said he looked older, as though the hours had pressed something out of him that he couldn't name. He never explained what he heard. He only said that Kolumbo had spoken to him, that the voice was deeper than sound, a certainty that nothing on the surface could ever translate. The recording was sealed in the archives of the small maritime museum in Thera. Those who have listened to it, quietly, in back rooms away from tourists, say it is little more than a series of pulses, a low beat, uneven, almost mechanical. But if you listen long enough, they say, you feel something behind it, a shape in the darkness that never quite steps forward, but never fully leaves. When the final report was published, it was stripped of anything speculative. The language was clinical: increased hydrothermal activity, accelerated dome growth, unexplained harmonic phenomena. No mention of the diver's solitary voyage, no word about the sediment trails, no suggestion that the crater was anything but an ordinary volcanic system with unusual behaviors. Yet everyone who had been there understood the omission. Because Kolumbo wasn't an anomaly to be solved, it was an encounter that no chart could hold. One geologist who had mapped dozens of vents across the Mediterranean described it best in a private note, scribbled in the margins of a survey draft. Some volcanoes erupt because they must. Kolumbo erupts because it decides. To this day, passing vessels sometimes report that their depth sounders behave strangely when crossing the Caldera. Readings drop to impossible depths. Echo returns warp or vanish entirely. A captain might watch the screen as it shows the seafloor folding open, a black hollow expanding beneath the keel, and then just as suddenly, returning to normal. In those moments it feels as if the sea is remembering something it doesn't often share, as if it is testing the edges of what it means to be observed. And though Kolumbo may sleep for decades at a time, the tracks in the sediment remain, a quiet record that something beneath the Aegean moves on its own schedule, answering to no tide, no tectonic drift, no human attempt to understand it. And someday, when it rises again, it will not announce itself with tremors or gas plumes. It will come as it always has, softly at first, the water warming in slow circles, the sonar dropping into hush, a presence rising through darkness that has waited longer than memory, a reminder that the ocean does not belong to us. It only tolerates our questions. Not many vessels make the slow approach to Eifuku Seamount. Even fewer linger. It sits beneath the restless skin of the Mariana Arc, a squat mountain of black basalt and ghostly white chimneys, exhaling plumes that never quite settle. To the untrained eye, it could almost look peaceful, like an underwater factory left running in perpetual isolation. But Eifuku is anything but dormant. In 2004, a survey craft called the Kermadec became the first to record the Champagne Vent, the place where liquid carbon dioxide bubbles rise in endless shimmering curtains. Divers descending in submersibles described the sensation as surreal, an illusion of rainfall turned upside down, droplets emerging from the earth instead of falling toward it. Each bubble caught the submersible's light, in a way no other vent did, glinting silver, and then vanishing into a darkness too thick for refraction. For the first few minutes of each descent, all was quiet, only the muted hum of the craft's thrusters and the soft hiss of respirators. But as the submersible neared the chimney field, the water began to feel heavy, not denser in any measurable way, but charged, as if the entire column were waiting for something to declare itself. Lights picked out the squat towers of precipitate, each chimney shaped by decades of mineral exhalation. They stood in uneven ranks, some leaning together in clusters like conspirators. Others were solitary, venting pale streams into the darkness above. No one had seen a system quite like this before. The temperatures were lethal. The dissolved Go2 concentrations defied most known limits for life. Yet life was there, thick mats of white bacteria, clinging to the chimneys like frost, crabs moving deliberately along the towers, and snail colonies as pale as moonlight. It was an ecosystem no surface dweller had ever imagined, a realm where carbon dioxide drifted like mist, and the chemical foundation of life was rewritten in real time. During one descent, a biologist noticed something peculiar. The vents weren't just exhaling, they pulsed. A slow, rhythmic surge of bubbles that grew in strength, then receded, as though some vast lung were breathing beneath the crust. Instruments logged the intervals. Every 6 minutes the pulse peaked, then subsided. Again and again, a heartbeat, impossibly slow, pulsing from somewhere deeper than any probe had yet reached. When the submersible edged closer to the largest chimney, an obelisk nearly 8 meters high, they spotted something that stopped all conversation. Embedded near the base, beneath an overhang of white crust, was an opening. It looked too precise for natural fracture, a narrow slit, just wide enough to slide a hand into, if any diver had been reckless enough to try. Light shone into it, revealed only darkness, but the bubbles rising from the slit were different, larger, slower, and within each a glint of something metallic. They collected a sample. The droplet that rose in the capture vial wasn't pure CO2. It contained fine particulate, microscopic grains of metal alloy, never recorded in vent deposits before. Some believed it was contamination. Others suspected a deeper, stranger origin. The sample container corroded from within in under a week. Later surveys used autonomous drones to record longer observations. Each time, the same pattern emerged. The vents pulsed, and with every surge the seafloor temperature rose fractionally, as though something enormous shifted under the mountain. You could almost imagine it turning in its sleep. When a mapping drone was piloted directly over the main vent field, it captured something that remains unexplained. For 2 minutes, sonar imaging showed a hollow beneath the chimneys, a vast chamber, perhaps a bubble of CO2 trapped within the rock. But as the drone hovered, the hollow shifted, contracted, expanded, and then vanished from the readout entirely. A geochemist reviewing the footage later described it in private notes as a cavity that didn't want to be seen. Fishermen along the Mariana fringes have their own language for Eifuku. They call it Ishi no Iki, the breath of stone. Long before any research vessel laid a probe on the summit, they warned each other never to fish above its crown. Nets came back shredded. Anchors sometimes returned polished smooth, as if dipped in acid. And there were older tales rarely shared of boats that strayed into the rising bubbles and never drifted back. When the last manned submersible departed the champagne vent, one of the pilots sat quietly as the hull climbed through the cold water column. He watched the shadow of Eifuku slip beneath them, the vent plumes fading into the distance like a memory dissolving in a dream. Later he wrote only one note in the mission log. It knows we were here. No further manned expeditions have been planned. And while the official reports describe Eifuku as a singular geological marvel, an anomaly worth studying for its rare chemistry, those who have descended into its fields of white chimneys know better. Some places on the ocean floor do not care whether you understand them. They do not welcome the instruments you lower or the lights you shine into their hollows. They are older than our questions, and they do not need to explain themselves. Top of form. A year after the first expeditions to Eifuku, a consortium of marine institutes funded a series of autonomous drone surveys. No pilot would need to risk the vent's corrosive haze. No human breath would condense against the viewports. The drones descended in a procession of quiet lights, their cameras sweeping the towers in endless looping arcs. The first days returned familiar images: white chimneys rimmed with frost-like bacterial crust, long rivers of bubbles drifting up in unbroken veils, crabs as pale as ivory clinging to the rock. It looked almost peaceful in the feed, but anyone who had studied the chemistry knew that every moment the drones remained down there. Their sensors were being eaten from the inside out. By the 4th day, one drone, designated Echo 4, was sent closer to the largest vent cluster. Engineers had rigged it with a vibration sensor to capture resonance from the pulsing exhalations. The device was meant to measure heat signatures, turbulence, and subsonic tremors, nothing more. But when the sensor activated, the drone's readings spiked. What came through wasn't random motion or seismic hum. It was patterned, a layered tremor that moved up and down in frequency with a kind of mathematical elegance. Analysts later described it as too ordered to be geology. The signature repeated in a long sequence that lasted nearly 20 minutes, then fell silent. Echo 4 continued its mission, but as it banked around the northernmost chimney, its camera caught something unsettling. One of the smaller vents had collapsed. The tower lay in pieces along the seafloor, its rim shattered into jagged fans. But it wasn't the break that made researchers fall quiet in the control room. It was the cavity revealed inside. Where the tower had stood was an opening that looked like a throat, a smooth shaft cut into the bedrock, rimmed in glistening frost that pulsed with the same strange rhythm as the larger vents. Out of this hollow rose a different kind of bubble, larger spheres that floated upward more slowly, turning as they went, each carrying a swirl of dark particulate that never settled. The drone inched closer, lights illuminated the shaft in sections. The deeper the beam reached, the more the interior shimmered like polished basalt. Then the feed cut out. At first operators assumed a power loss, but the drone's telemetry continued, battery levels stable, propulsion responsive, only the camera, dead. After several minutes of reset attempts, a technician manually toggled the power relay. The camera flickered back on. The drone had moved, not by much, just a few meters, but enough that its heading no longer matched the previous orientation, and the cavity was gone. The broken chimney still lay collapsed, but the hollow in the rock was no longer visible. In its place was a smooth depression in the crust, rimmed by white crust like all the others. Footage was reviewed frame by frame. No transition was recorded. One moment, the cavity was there. The next, it wasn't. Echo 4 was ordered back to the surface. As it climbed through the water column, operators noted a faint vibration that never appeared on previous ascents. Not turbulence, more like a shiver traveling through the hull. Every 3 seconds the vibration peaked, then faded. An echo of the pulsing sequence recorded earlier. The drone was recovered intact, but its forward casing was etched with shallow lines, dozens of them, curving in arcs across the metal shell. Not scratches from collision, not chemical erosion. Lines drawn as if by some invisible stylus. The markings were analyzed under magnification. No one could say for certain what they meant, but their spacing resembled wave harmonics, patterns that seemed almost to speak. Weeks later, when researchers compared the vibration logs with the first expedition's sonar data, they discovered a troubling alignment. The pulses rising from Eifuku matched a deeper signature, one recorded miles beneath the vent field. It was as if something enormous, hidden below the seafloor, was responding to the chimneys above. Geologists speculated about a superheated reservoir, a magma body too vast to map, but others, quietly, suggested something older, a system of cavities and conduits that remembered the shape of every intrusion, every probe, every camera, and adjusted itself accordingly. Fishermen along the Mariana Arc do not need such explanations. Their stories have no diagrams, no charts. They speak instead of the sighing mountain, a place that is alive in ways no one should tempt. And when the last drone was recovered, its hull scarred by lines no tool had made, the research team made a quiet decision. No further dives would be commissioned without years of study. Eifuku would remain unvisited. It does not need more visitors, because in the dark beneath the chimneys, in the slow rising of its carbon dioxide veil, something waits. It is not hidden because it fears discovery. It is hidden because it has never needed to show more than a glimpse of itself. Months passed after Echo 4's return, but the footage haunted the research team. Even the most rational among them admitted something about the collapse, and the impossible disappearance of the hollow felt intentional, as though the vents had chosen to reveal a single glimpse and then sealed themselves again, indifferent to curiosity or caution. Funding remained in place, and with it, the pressure to send another machine. Echo 5 was designed to withstand anything the first expedition had encountered: stronger plating, redundant cameras, and a reinforced data core shielded against corrosion. But what they feared most wasn't failure, it was success. What if the cavity opened again? What if the lines returned, etched deeper this time? The morning Echo 5 descended, the sky above the Mariana Arc was a flawless blue. Surface conditions calm enough to pretend the world beneath was equally still. But the team had learned better. The first 1,000 meters of water were empty, featureless darkness. Then came the gradual glow of diffuse vent light, tiny motes swirling like snowfall over the long white chimneys. The largest tower, nicknamed Pillar 1, still stood, a 40-meter monument, to a process no one entirely understood, but something about it looked different. The crust on its rim had thickened, and the plume rising from its crown moved more sluggishly, each bubble larger than Echo 4's recordings had shown. Echo 5 drifted closer. Cameras scanned for the fracture Echo 4 had discovered. No sign of it, just a smooth, unbroken expanse. The drone circled, its vibration sensors awake and listening. For nearly an hour, nothing happened. No anomalies, no pulses, no sign that the vent field had registered its presence. Then, without warning, a tremor rippled through the seafloor. Not an earthquake, more like a shudder in something alive. One of the smaller vents collapsed in a sigh of silt and gas. The plume thickened, and when the particles cleared, the cavity had returned, identical to the first time. Same diameter, same smooth walls, same impossible depth, as if the seafloor had simply chosen to reopen the wound. Echo 5 hovered at the lip. Engineers debated whether to lower the cameras inside. The pilot's hands trembled over the controls. Even through the screen, the cavity seemed to absorb attention, an opening that promised more than any instrument could measure. Finally, a decision was made. The probe arm extended, its sensor package, equipped to measure heat, vibration, and particulate density, slid into the cavity's throat. The readings arrived in a steady stream, temperature rising, pressure holding, carbon dioxide saturating the current. But then came a number no one expected: depth. The cavity was bottomless. No matter how far the probe extended, the return ping never arrived. Even the sonar's longest range, 10,000 meters, met only absence. And then as Echo 5 reached the furthest extension of its tether, the vibration sensors came alive. A deep pulse began, low enough to shake the drone's casing. Not random, not seismic, a regular rhythm, rising in amplitude with each beat. Everyone in the control room fell silent. On the screen, a new motion appeared, not from the cavity, from the chimney itself. The vent's crust was moving, cracking open along invisible seams, releasing thick streams of bubbles that twisted in tight columns before dissolving into the black. The pulses continued, faster now, carrying a pressure wave that made the drone's lights flutter. One by one, the cameras flickered and died, until only the vibration feed remained. The drone began to drift backward, though no command had been given. Operators tried to override, to stabilize its position, but the propulsion system didn't respond. In the darkness, the drone retreated, moving meter by meter away from the cavity, as if some unseen hand had grasped it and decided no more. At last the cameras sparked back to life. The cavity had vanished again, replaced by a smooth crust. The vent plume slowed, the pressure normalized, and the seafloor returned to stillness. Echo 5 systems reinitialized, thrusters engaged. Telemetry resumed its quiet scroll of numbers across the monitors. And then just before the drone was ordered to ascend, the vibration sensors recorded a final sequence. A single pulse higher in pitch than any before. 3 seconds of silence. Another pulse. 3 more seconds, and then nothing. The pattern repeated, identical to the marking intervals etched on Echo 4's casing. When Echo 5 surfaced, it was clean. No lines scored across its hull, no corrosion visible. Only one detail was different. The sensor array that had entered the cavity was warm to the touch. So warm the technician recoiled. And embedded in the fine silt clinging to the probe tip were tiny crystalline structures, each shaped like a perfect helix. No one could identify them. Some in the expedition insisted they were mineral formations, salt precipitates from the vent's unique chemistry. Others quietly believed something else had been left behind. Whatever waits beneath Eifuku doesn't announce itself with eruption or collapse. It opens, slowly and without fear, to show that all of our instruments and our names for things, chimney vent fissure, are only guesses. And when the cavity closed for the second time, the research team understood that the real discovery wasn't the shape of the hole. It was that the seafloor had decided when to show them, and when to stop. The return voyage to port was marked by a quiet no one could quite shake. Not even the ship's engines, rumbling through the decks, could drown out the feeling that something had been left unfinished, that the cavity in the vent floor hadn't merely closed, but had made a decision about them, about how much to reveal. In the days that followed, the footage was examined, frame by frame. Experts in marine geology, deep sea biology, and geophysics all offered theories, some mechanical, some chemical, some almost comforting in their familiarity. But none could account for the consistency, the identical dimensions of the cavity, the precise sequence of pulses, the sense, unspoken but shared, that whatever intelligence animated the vent field was not incidental, and the crystalline helices. The lab's first report found no matches in the global mineral database. Their composition was ordinary enough. Calcium, sodium, traces of iron, but their arrangement defied the rules of simple deposition. Each one was a perfect twin of the others, as though grown deliberately, like a lattice intended to be read, rather than measured. The technician who had first touched the probe's warm casing insisted that when he closed his eyes, he could still feel it vibrating, a fine internal rhythm, independent of memory. He was checked for neurological side effects. None were found. He was cleared for duty. But later, alone, he began marking the pattern on scraps of paper, the sequence of intervals, the count of pulses. He couldn't have said why, only that it felt wrong to forget. In the research reports, the language grew careful. The cavity was now called the anomaly. The vent field became the site. But everyone aboard that last expedition knew the words were a defense, a way to avoid saying what they believed, that the vent was watching them, measuring their readiness, perhaps deciding what to show next. A proposal circulated for a third mission, an expedition not just to observe, but to attempt direct sampling inside the cavity, if it reopened. The suggestion met silence. Funding bodies were hesitant. Crew members declined to return. Even the drone operators, used to monotony and risk, spoke of the last dive as something apart, a trespass that had been permitted only once. Months later, a different vessel passed near the Eifuku Chimneys on a separate survey. Their sonar picked up nothing unusual. The vent field was calm, no columns of gas, no hidden fractures, only a deep spreading warmth, measurable, even at distance, as if the sea floor itself had become aware of being studied, and had chosen to remain opaque. One evening, the lead biologist from the first Echo mission received a private message, a small encrypted file with no sender. Inside was a snippet of vibration data, the final recording from Echo 5. When she played it, the rhythm was familiar, identical to the pattern etched into the first drone's hull, identical to the spacing between the pulses recorded during the second descent. But this time, as she watched the waveform, she noticed something she hadn't before, a small irregularity. Every eighth pulse, there was a doubling, like an echo riding on the main signal. When she isolated the overlay, she felt her skin tighten. It was a second pattern, a sequence hidden inside the first. She listened again, leaning close to the speaker, and though she could never prove it, never show it in the data to anyone else's satisfaction, she was certain the rhythm wasn't random. It was counting. The thought burrowed into her mind like a splinter. A count of what? Time, distance, attention. Something about it felt less like measurement, and more like an invitation, or a warning. On the last night before she resigned from the project, she sat alone in her office with the lab's lights off, the speakers turned low. She played the signal one final time, and thought of the cavity yawning open under 40 meters of white stone, the way the darkness inside had seemed to pull at the camera's focus. The final pulse in the recording was different, louder, almost clear. She leaned close, hardly breathing, and just before the file ended, the vibration changed. It rose and fell with a cadence that no longer felt geological. It felt like a voice. No syllables, no language. Just the shape of intention, resonant and final. When the playback ended, the office was silent. She sat there a long time, heart knocking against her ribs, and understood that no funding, no analysis, no chart could change the truth. The Eifuku Chimneys were not merely an accident of pressure and mineral, they were an aperture And someday, when curiosity outweighed caution, or when the seafloor decided it was time, that aperture would open again, waiting, as it always had, for someone to answer. Most expeditions to the Aleutian Ridge are drawn by the promise of new crust forming, where the Pacific Plate grinds against the North American. The charts show a scrawl of fracture zones and seamounts, a geography shaped by forces too slow to witness in real time. But Healy Volcano had always been a quiet name on those charts, marked as dormant, unremarkable, overshadowed by the more violent neighbors that vent gas and shudder the seabed. Until the morning a seismic array stationed off Unalaska Island began returning a series of signals that didn't fit any known eruption profile. Not tremor, not harmonic quake, just a single sustained resonance, a low layered chord that built for nearly 6 hours. The waveform was almost melodic, rising in intervals like a scale being tested by an unseen hand. By the time the signal ceased, the sensors closest to Healy had recorded a second anomaly, a sudden spike in temperature along the ridge crest, enough to liquefy pockets of sediment and collapse a small slope into the trench. When a research trawler reached the area 3 days later, the water was still warm, too warm, and the currents pulled north in a slow spiral, carrying silt and something stranger. Divers described it first as particulate, black flecks that didn't dissolve, didn't disperse, just drifted in slow orbits around the vent. But under magnification, the flecks were uniform, hexagonal plates, thinner than paper, layered with fine striations no one could explain. Samples sent to labs in Anchorage and Seattle came back inconclusive. The plates weren't volcanic glass or any known mineral. They were engineered, somehow, arranged into identical microstructures, like scales on a creature too large to imagine. The main vent itself had altered. Once a narrow fissure, it now gaped open in a circle nearly 15 meters wide, rimmed with pale rock. At its center, nothing, not darkness, absence. Sonar bounced back blank. Cameras refused to focus. It was as if the cavity rejected observation, a wound in the earth that had no intention of healing or explaining itself. Over the following month, the resonance returned twice more. Each time, it grew clearer. The patterns nested in on themselves, rising and falling in careful measures, never repeating exactly. Some thought it was tectonic language, a kind of lithic Morse describing processes humans had never classified. Others, more quietly, believed it was a signal in the truest sense, a broadcast waiting for an answer. One vessel deployed an autonomous probe, equipped with vibration mapping sensors. It descended to the edge of the vent and paused. For nearly an hour, its instruments recorded the same layered chord that had first woken the ridge. As the probe drifted closer, its onboard spectrograph captured something no one could have anticipated. The microplates were vibrating. Each hexagonal fragment pulsed with the resonance, shifting minutely in alignment with the vent's rhythm. When the probe crossed the threshold, everything went still. The resonance stopped. The plates ceased their rotation. In that silence, the seabed seemed to hold its breath. Then the feed ended. Not cut, not lost, simply ceased. A frame frozen on the last image, the vent's rim receding, the black at the center consuming the camera's field of view. Recovery efforts never retrieved the probe, and though seismicity eventually fell back to background levels, the temperature around Healy remained higher than any vent in the region. When the trawler left, the crew noted that the water just above the vent was flecked with the same fine scales, coiling upward in slow, deliberate spirals, as if the volcano were exhaling something ancient, as if it was remembering how to speak. The research community tried to dismiss the resonance as harmonic tremor, an echo of magma shifting deep beneath the crust. But no ordinary process left the seabed altered in such clean geometric ways. Months after the first resonance, the next expedition approached the coordinates, where the vent had opened. This time, they carried heavier equipment, deep-towed magnetometers, high-resolution sonar, a new generation of autonomous probes with redundant systems. As the ship crept over the site, the water grew dense with suspended silt, and those same black hexagonal plates. The plates didn't scatter like dust. They floated in quiet choreography, spinning slowly on unseen currents, aligning their faces toward the hull's running lights. No organism should have survived that heat. No mineral should have formed those shapes. But as the deck crew lowered the instruments, the plates drifted upward and brushed the cables like the exploratory touch of a fingertip. The magnetometer was the first to fail. As it passed 50 meters above the vent, its readings began to wobble, then invert entirely. North became south. Positive flipped to negative. A technician called it magnetic noise. But the frequency was too clean, too stable. It felt like a message spelled out in inversion. Below, the vent had widened further. Sonar revealed a perfect circle nearly 20 meters across, with edges sharper than cooled lava should allow. The seabed sloped inward, like the throat of a funnel, and in the center, an anomaly, a shallow dome of unknown material, smooth and utterly black, pulsing with a faint radiance invisible to the naked eye, but bright as a flare on the infrared camera. When the submersible probe dropped through the upper water column, the plates parted in a slow spiral, making way as if something had told them to move aside. The probe's spotlight swept the dome and caught on the faintest markings, curved repeating symbols that glimmered before fading into the shell again. The symbols didn't match any known alphabet. They weren't scoured into the surface. They were woven into it. Some on board called them decoration. Others insisted they were instructions. A gentle tremor shivered through the hull. Not violent, more like a heartbeat too vast to comprehend. The probe's vibration sensors began to oscillate again. The same rising chord layered over itself until the water quivered with invisible force. The crew watched as the black dome cracked open. It didn't shatter. It didn't explode. The surface simply split along a perfect seam, revealing an interior as dark as the vent itself. The probe's cameras focused, struggling to resolve depth. All that returned was emptiness, so absolute it overexposed the instruments. The vibration stopped, and in the silence that followed, something emerged. Not an object, not a creature. A shape vague as if wrapped in thermal mirage, taller than the probe, motionless. Sonar recorded no mass. Pressure sensors logged no displacement, but the cameras saw it. A pillar or spine, rising from the black, etched with the same symbols as the dome. It held there for less than a minute. Then it folded back into the vent, swallowed by darkness, so complete it erased its own memory. When the probe began its ascent, the plates closed in, drifting up along the tether like spores searching for something familiar. By the time the probe cleared the rim, every sensor had failed. On the surface, the lead technician kept replaying the footage. Each time, the shape resolved a little more. Angles too precise for geology, too alien for life. He stopped trying to explain it. After the 10th loop, in the hours that followed, the resonance did not return. The vent held its silence. The water grew still, and the ship drifted on a sea that no longer felt empty. For weeks afterward, those who had watched the footage dreamed of black pillars rising through glassy water, not attacking, not welcoming, just waiting, unmoved, unaging. No one volunteered to return, but the plates still drift in the currents, their dark surfaces flickering in patterns no one has deciphered. And in the maps of the ridge, the name Healy Volcano has been given a new notation, one the public never sees. Not dormant, not active, other. Farther below the surface, where the weight of the ocean flattens all motion, the ROV drifted toward the heart of Healy's caldera. The slope fell away into a bowl-shaped depression, its edges lined in terraces that looked almost too precise for geology alone. The machine's floodlights threw long shadows across walls, etched with cracks that glowed faintly, pale blue veins mapping where heat seeped up from fractures hidden miles deeper. As the descent continued, the operators began to notice something curious. Each of those glowing cracks pulsed, but not all at the same time. It was as if Healy's vent network were breathing in segments, like a massive throat adjusting its rhythm. Data streamed in, the pressure waves, the gas composition, the shifting slope angles. It all should have been random, chaotic. Instead, the readouts coalesced into a strange regularity that no one could name. The vessel eased closer to the central vent. Here a cone rose from the caldera's basin, capped by a crown of sulphurous chimneys. Around them, currents curled upward in slow spirals. Every so often, a shard of rock would detach from the rim, tumble through the haze, and vanish into the fissure's dark throat. The sonar traced each descent, but the echoes never returned. It was as though everything that fell inside was swallowed without a trace. When the ROV tilted its cameras to record the base, the operators saw something that made even the most seasoned geologists hold their breath. The cone wasn't just spewing gas and ash, something else coated the rock's layers of delicate white filaments, like cobwebs woven through the heat. They clung to the surfaces without burning, billowing in currents that carried no life. No one had ever documented microbial mats surviving temperatures this high, and none had formed in such structured patterns. The lead researcher leaned closer to the monitors, lips parted in disbelief. She traced the lines of filament as they curved in spirals, crossing each other at clean intervals. No randomness, no chaos. It looked deliberate, as if some unseen process had etched the threads across Healy's summit to mark a boundary or trace a memory. Suddenly the lights flickered, the feed wavered, and in that split second of darkness, the ROV's depth gauge dropped by nearly 3 meters. No current, no vibration. It simply fell, like the sea floor had let go of gravity. By the time the lights recovered, the filaments were gone. Only bare rock remained, steaming under the floodlights. In the control room, no one spoke. After the shock, the ROV pilot pulled the vessel back in slow retreat, spiraling up the Caldera walls to safer depth. As the machine climbed, its cameras swept over terraces hidden in darkness a moment before. Each ledge bore fresh fractures, thin and bright with seeping gas. The volcano was still stirring, an old giant unhurried by the passage of ships or the nerves of humans. Above the caldera rim, the water grew warmer, clouded by ash that drifted like a blizzard, turned sideways. Fragments of cooled lava settled over the ROV's hull in delicate layers. The sensors pinged quietly, recording every grain. On the ship, the team watched in a tense, collective stillness, cataloguing each second as if observation alone might keep Healy's mood in check. Near the upper slope, the cameras caught a final unsettling detail, a wall of stone scored with vertical grooves, perfectly parallel. They ran from ridge crest to basin floor in a single unbroken sweep, too smooth to be tectonic, too aligned to be chance. Each groove glowed faintly along its edges. A geophysicist whispered that they looked like claw marks pressed through cooling rock, but no one answered. The ROV hovered there for long moments, collecting final data. As it turned to begin ascent, the slope quivered, a tremor, small but definite. The lights danced across the groove walls, and for a heartbeat, the cameras captured something shifting deep inside one of the vents. Not a shape, not a shadow, just motion, something sliding further below the crust, as if to avoid the intrusion of light. The pilot didn't wait for consensus. He pulled the ROV higher, faster, past the terraces, and up toward the safety of the upper slope. Each meter restored a measure of calm to the sensors, until at last the hull crested over the caldera rim, and the instruments fell quiet again. Back on deck, the team released a breath they hadn't realized they'd been holding. No one had answers. No one tried to guess. In the lab notes, they wrote only what they had seen: fissures that glowed in rhythm, filaments that vanished in the dark, grooves carved too clean to be nature's work. And in the silence of that final ascent, a sense that Healy had watched them watching it. Not with malice, not even with curiosity, just a patient awareness, older than any language, content to remain buried another 1,000 years. Hours have passed since we began our descent. Hours spent tracing ridges no map can hold, watching volcanoes rise from blackness, listening to the sea, remember things older than our species. You've seen the fire that grows in darkness, the hidden calderas that exhale ash into silence, the newborn islands that break the surface and vanish again without witness. You've felt it too, haven't you? That pull at the edge of understanding, the knowing that all this motion, this eruption, collapse and creation, goes on whether or not we measure it, whether or not we name it. Out here there are no straight lines, no borders, only pressure and time, only currents that circle through centuries, carrying secrets in their cold hands. If you close your eyes now, you might hear it. Some faint vibration rising through the headphones or the walls around you. Not danger, just the old unhurried voice of the planet, breathing beneath your quiet room. Let it remind you, even in stillness, something is always moving. Even in darkness, something is always alive. Before you go, tell me, where are you watching from tonight? And what time is it there on your side of the world? Leave a comment below. Let's see how far these stories can drift. Thank you for staying here, through every hidden vent and ash plume, every lost island and glowing ridge. Wherever you are, may the quiet stay with you. Until next time, sleep well, and remember the ocean is never really silent.